Good morning, everyone. It is 9 o'clock, and welcome back to the California WaterFix petition hearing. In case you've forgotten overnight, this is Tam Dodek, Board Member and Hearing Officer. To my right are Board Chair and Co-Hearing Officer Felicia Marcus and Board Member DDD Adamo. To my left are staff assisting us today, Dana Heinrich and Diane Riddle. Couple of quick announcements. If an alarm sounds, we are required to evacuate immediately. Please take the stairs and not the elevators down to the first floor and exit out to the park. If you cannot use the elevator, you will be directed to a protective vestibule. This meeting is being recorded, webcasted, and there is a court reporter present. So when you are speaking, please use the microphone. And lastly, and most importantly, I'm now turning to look at Ms. Riddle. Please take a moment to put your phone on silent or do not disturb. Again, if you think it's set that way, please check, Ms. Riddle. All right. With that, I believe we are ready to proceed to petitioner's second panel. Would you have your witnesses rise and raise their right hand? Do you swear or affirm that the testimony you are about to give is the truth? If so, answer yes, I do. Thank you. You may be seated. Mr. Mizell?
Yes, good morning. The panel you have before you today is on the engineering testimony. These are the chief, yes, very exciting technical information that is going to go on today. So the three panel members are John Bernarski, Sergio Valles, and Gwen Buchholz. As we indicated before, we had a fourth panel member who is currently not available, but should his expertise be required, we'll bring him back for cross-examination purposes at a later date. So before we begin, Mr. Bendarski, would you please tell me if DWR Exhibit 17 is a correct copy of your statement of qualifications?
Yes, it is.
And is DWR 57 correct copy of your testimony?
Yes, it is.
Thank you. Sergio, is DWR 18 a correct copy of your SOQ?
Yes.
Microphone?
Yes, it is. Yes, it is.
Thanks. And is DWR 58 a correct copy of your testimony?
Correct.
And Ms. Buchholz, is DWR 32 a correct copy of your SOQ?
Yes, it is.
And is DWR 72 a correct copy of your testimony?
Yes, it is.
Okay, thank you very much. If it's the right time, I can have the panel begin their direct testimony. Okay.
Please do.
Mr. Bendarski, can you please summarize for the hearing officers your written testimony using the slides you've prepared?
Yes, thank you. Good morning, members of the board. We appreciate this opportunity to present to you the engineering aspects of the California WaterFix. There'll be three specific areas that I'll be addressing today in my testimony. I'll be talking about the proposed facilities for the California WaterFix and the refinements that have been made over the last several years as we've been going through the EIR-EIS process. I'll be talking also about the construction potential effects to water users and the mitigation measures that have been incorporated into this project, and also finally talk about flood protection measures. There are 5 areas of features that I will be discussing today that together comprise the California WaterFix. We have the intake facilities, the tunnels, FOREBAYs, Clifton Court pumping plant, and the head of Old River operable gate. As the engineering team has been developing the engineering components of these facilities, there have been a number of aspects that we have worked to incorporate into developing all of these components into a cohesive system. Let me go through those just briefly. We've been applying all of the key parameters given to us by the Department of Water Resources to give them a fully operational and functional system. We've been striving to reduce, minimize, or eliminate any impacts to the surrounding areas in the delta that these facilities will be constructed in. We've been responding throughout the process to community input that we've received along the way from various public meetings and responses to comments. We've been striving to improve the system flexibility for future operations of the system, and also making accommodations to improve system efficiency overall for the California WaterFix system. I'm going to present now a series of panels that will walk the board through some of the major revisions that have been made to the California WaterFix over the last several years. And this first panel represents the system as it was characterized when the administrative draft of the project was issued in July of 2012. This was a 15,000 CFS system with 5 river intakes, pump stations at each of those 5 river intakes, a large intermediate forebay as we referred to it, and then what we called an intermediate booster pump station that was located near that intermediate forebay. And I'll go into more detail on these specifics. I know these graphics are a little bit small, but again, this was a 15,000 CFS system, and it conveyed the water through 2 33-foot diameter tunnels down to Clifton Court forebay. Now, responding to comments that we had received after the draft EIR was issued, revisions were made to the program. The capacity was revised to 9,000 CFS. We relocated and revised the size of the intermediate forebay, reconfigured the alignment of the tunnels so that there was a greater use of public lands, and to avoid some areas that we had received comments on, we relocated the terminus of the project at the north end of Clifton Court. After that time, a number of optimizations and revisions were made to the project again, and these were issued in the revised and recirculated EIR in July of 2015, and that is the present project that is in front of the board for your review. And this project now includes, we still have 3 river intakes. It is still a 9,000 CFS project. However, we have moved the pump stations from each of these intakes down to the south end of the project. So under the current configuration, the water will now flow by gravity from the Sacramento River approximately 40 miles south to Clifton Court. And at that point, we have a 9,000 CFS pumping plant that will lift the water from the tunnels and place that into the north part of Clifton Court. So now I'm going to kind of walk through some of the engineering refinements that we have made over the last several years to address, again, some of the comments that we have received to the EIR, comments that we've received from actually speaking with the community, and also as we've revised the EIR, reducing other impacts along the project. 2013 configuration of the intakes included pumping plants at each of the 3 river intakes. These were 46,000 square foot 2-story buildings, along with all of the mechanical and electrical equipment. These would require large high voltage transmission lines to be brought into each of these 3 sites in order to power these facilities. The first revisions that we've made to that was to remove the pump stations from these locations and combine the 3 pump stations into 1 down at Clifton Court. This allowed us to eliminate, of course, the construction of the pump stations, but also remove the high voltage transmission lines that would be there permanently if otherwise we had pump stations at those locations. Another revision, and this appears in the recirculated EIR, was that we reconfigured the sedimentation basins that collect the water that come through the screening structures along the intakes. These sedimentation basins are very important in that they will drop out any sediments that are coming down the Sacramento River that we want to keep out of our tunnels. So previously, we had concrete sedimentation basins that were supported by thousands of concrete piles that would have to be driven into the ground or constructed into the ground. So by turning these now into earthen line basins, we've been able to reduce the amount of concrete at these structures by about 80%. Our feeling is that this has significantly reduced the construction impacts at each one of these 3 intake structures. We're also proposing to use a series of slurry cutoff walls that will actually ring the sedimentation basin sites, and you will see this in a following video. But these slurry cutoff walls will effectively isolate the groundwater, the subsurface water within the sedimentation basins from the surrounding areas, so that we will be able to dewater inside the sedimentation basin area for our construction activities without affecting surrounding groundwater levels. So I mentioned earlier, we relocated and resized the intermediate forebay. You have here the original intermediate forebay when we had a 15,000 CFS project. The intermediate forebay by itself was approximately 850 acres. You can see down below it a hashed box. That was the intermediate pump station. So collectively, these 2 structures were approximately 1,000 acres. They were located on the Pearson Tract, close to the intakes. They would collect all of the water from the 5 intakes at that time. You can see at the right of that slide, that's the Stone Lakes Preserve area. So it was located very close to the Stone Lakes Preserve area. We have since that time relocated the intermediate forebay and dramatically reduced its footprint. So the footprint of the forebay now is approximately 97 acres, and with the hatched area, which is an overflow containment area, it's approximately 125 acres there. So we've reduced the overall footprint of the intermediate forebay by about 8-fold through this process. We've moved the intermediate forebay now to the Glanville Tract, so it is away from the Stone Lakes Preserve area. We've made some modifications down at the Clifton Court. Originally, in the original draft EIR, we had the tunnels terminating at the north end of Clifton Court. At that point, there was going to be a siphon under Italian Slough that would bring the water, the screened water, into the north portion of Clifton Court. We have now terminating the tunnels on DWR property at the northeast corner of Clifton Court, so there's no requirement for a siphon underneath Italian Slough at this point in time. I might just point out that all the water diverted from the 3 screened intakes, the screened water will be delivered into the north half of Clifton Court. Clifton Court will be bifurcated with a divider wall so that all the screened water is contained in the north half of Clifton Court, and then the south half of Clifton Court will be expanded in order to give DWR the same amount of operating volume in Clifton Court as they have now. So we'll be expanding Clifton Court to the south so that they have the same operational volume, so that when we're in the dual operational mode, they can continue to bring water in from the Old River intake inlet into Clifton Court, and it will continue to operate as it is. The current Skinner fish screening facility will also continue to operate as is. Our proposed California WaterFix will not impact the existing Skinner fish facility. So now we've put all the components together into the system. I'll just walk the board through all the components so you can see this as it is presently structured. You can see the tunnel alignment there from north to south, but we have our 3 river intakes along the Sacramento River. As we're moving south, there's actually 3 tunnels that collect the water from these intakes and then bring that water to the intermediate forebay. The intermediate forebay allows us to combine those 3 individual flows and split them equally between the 2 main tunnels that proceed from the intermediate forebay south. At the bottom near Clifton Court, as I mentioned before, we have a new pumping plant, a 9,000 CFS pumping plant. And then we have the Clifton Court forebay, which I just briefly mentioned in the previous slide. Clifton Court will be bifurcated in half, and in the south half of that forebay will be expanded to the south. Now we have the tunnels. As I mentioned, we have what we call north tunnels and then the main tunnels. The north tunnels, there's a collection of 2 different tunnels, approximately 13 miles. They will be collecting water from the 3 intakes and bringing that down to the intermediate forebay. The main tunnels, or the twin tunnels, are the 40-foot diameter tunnels that will run from the intermediate forebay 30 miles, approximately 30 miles south, down to the pumping plant in Clifton Court forebay. Now taken all together, this is a very large tunneling project. The tunneling construction cost represent about approximately 2/3 of the overall cost of the California WaterFix. Now, we have, through our engineering work, done a lot of investigation into the size of projects that we feel are can be readily developed, and by breaking up the contracts on the main tunnels into actually 4 smaller contracts, and then breaking up each of those contracts is about 7.5 miles of tunneling, breaking those up with intermediate vent structures halfway through, we've been able to segment this project into what we feel are tunneling reaches that can be very successfully designed and constructed by qualified tunneling contractors. We've done quite a bit of work researching the industry and understanding the capabilities on a global basis of the capabilities of tunneling contractors and also of manufacturers of tunnel boring equipment, and we feel quite confident that there is a large inventory of both tunneling machine capability and also tunneling contractors that can successfully implement this project. Finally, the final component, the California WaterFix, is the operable gates located at the juncture of where the old river splits off from the San Joaquin River. This is the location where DWR presently installs a rock barrier on a seasonal basis, so there will be a permanent operable gate, and I'll discuss that a little bit further on in my testimony. This is like a flow diagram, just kind of breaking down the various components of the California WaterFix. We have the 3, starting at the left, the 3 river intakes, each one sized at 3,000 CFS. The size of these intakes is consistent with other successful screened intake structures along the Sacramento at Glen Colusa and Tehama-Colusa water districts. And so we feel that, again, the technology and the engineering has already been developed for designing and constructing these types of intakes. Sedimentation basins immediately downstream of the intakes will settle out any particulate matter before the water is deposited into the 2 smaller tunnels. It's actually shown as 3 here, but 1 tunnel joins there. You see a 28-foot diameter tunnel joins a second tunnel at the intake number 3, and then 2 tunnels flow into the intermediate forebay. Again, under certain water level conditions in the Sacramento River, water will be able to flow by gravity from the Sacramento River down to the combined pump plant at North Clifton Court. And under certain water level conditions, that water will be able to overflow at that point and go directly into North Clifton Court without any pumping. Under the other remaining operational conditions, the pumps will have to be operated to lift that water into Clifton Court. After the intermediate forebay, then, you can see the twin 40-foot diameter tunnels convey the water equally down to the combined pumping plant and then into North Clifton Court. Now we'll talk about the intake structures from an engineering perspective. The engineering design team was provided with a series of design criteria that we utilized to determine the size and configuration of the intake screens and the structures that go with those screens. This criteria was developed by the Fish Facilities Technical Team, separate from the engineering team. And the size of the intake structures was determined by that team to be consistent with the size of other intakes that have been successfully developed on the Sacramento River. So you can see the single intake maximum capacity is 3,000 CFS, 3 intakes along the river for a maximum capacity of 9,000 CFS. And then one of the important criteria in sizing these screens is the screen approach velocity of 0.2 feet per second to protect the smelt. That is the smelt criteria that will allow the smelt to successfully pass by the screens without being entrained into the screens when the screens and the intakes are in operation. So this is an overview of the intake structures. Again, you have the screens and a collection box system that's along the river. Channels will, box conduits or concrete box channels will convey the water from this distribution box into the sedimentation basins, and then the water will flow by gravity to the outlet structure, which is actually the starting point for the tunnels. The tunnels are at the bottom of that outlet structure, and from there the water will flow then by gravity and be collected at the intermediate forebay. This is a three-dimensional rendering of what the intakes look like. You can see the pile foundation and the cofferdams will all be located below ground, and then above that will be the concrete structures that will house the screens. The screens are shown in a light green color there, just above the red cofferdam. Those screens are about 15 feet high. Their exact dimensions depend on which intake structure you're at. The darker green color is just a blank panel. That is not the screen structure itself. But once the water flows through the screen, it'll be collected in a distribution box in the backside. And we've broken up the intake structures into 6 specific areas. And you're seeing 1/6 of a intake structure here, with the 2 box conduits that then lead away from that. And the reason that we did that was we wanted to ensure that we would get even flow on a consistent basis across all of the screens so that we could ensure a uniform flow through the intake structures. These box conduits are important in that there are flow meters inside of these box conduits, and where you see the call out for a slide gate, that is actually a control gate that will adjust up and down to ensure an even flow through each of these 1/6 modules of the intake structures. And in that way, we'll be able to successfully control the amount of water that's diverted from each of the intake structures. So each of these intake structures will be built in these 1/6 modules, and then each intake structure will work in conjunction with itself to be able to evenly control the amount of flow that's being diverted from the Sacramento River down to the pumping structures in the south. As I mentioned earlier, the water flows through the sedimentation basins and then drops into an outlet structure, which is actually the starting point for the tunnels down below. The water will drop anywhere between about 100 to 125 feet at the intake structures before it enters the tunnels. Okay, now move into the next part of the presentation where we'll talk about some of the groundwater or subsurface water control measures that we have planned into the California WaterFix. And there's 4 different components that I'm going to discuss: slurry cutoff walls, tow drains, the tunnel lining its system itself, and then finally some of the geotechnical studies and monitoring programs that will be undertaken as we move forward with the design and the construction of the facilities. So the slurry cutoff walls are intended to hydraulically isolate the construction areas for dewatering. We will need to dewater areas in order to be able to construct the facilities, and in order to dewater those areas without impacting surrounding groundwater levels and groundwater wells, we're going to be constructing a series of slurry walls to isolate our construction areas from the surrounding areas. We will also be utilizing the slurry walls to help us control seepage from any of the forebays and embankments that we will be constructing. And you'll see a cutaway later on that shows how these slurry walls will be built into any of the levees that we will be constructing as part of these forebays and sed basins. We'll also be using a series of tow drains with any of the levees and embankments that will allow us to collect any seepage water so that it will not be flow outside of our containment area. Seepage water is a normal occurrence for levees. They can't be entirely waterproof, but we want to be able to collect that water and then divert it back into our system rather than it becoming nuisance water surrounding our project site. Secondly, the tunnel lining system, extremely important. We're going to talk about that in a little bit more detail in a few minutes, but the tunnel lining system is designed to be constructed in a way that will give us extended lifetime of basically a waterproof tunnel environment, whether the tunnels are operating in order to prevent exfiltration from the tunnels when we're in operation, or if the tunnels are dewatered to prevent infiltration of groundwater into the tunnels. Let's talk a little bit about dewatering and the use of the slurry cutoff walls as we're proposing. In the Delta and the areas of the California WaterFix, the groundwater level will be virtually at the groundwater surface or very close to it, which would make it very difficult to construct the WaterFix facilities without doing a dewatering operation. In the initial drafts of the EIR, DWR had recommended the use of dewatering wells, and it disclosed that if these dewatering wells were used, there would be a very widespread cone of influence and depressed groundwater levels around these dewatering sites in order to dewater to the level that would be needed for our construction activities. Since that time, we have modified our proposal and are instead proposing to use what we call slurry cutoff walls that will be installed around the perimeter of all of our construction sites in the Delta, in particular the intake structures, the intermediate forebays. And these will allow us to basically isolate our construction sites and the groundwater in those construction sites from any of the surrounding areas. Once the slurry cutoff walls are installed, we'll be able to dewater that area without affecting the surrounding groundwater levels. It's intended that the slurry cutoff walls will be developed and extended down to a depth that they intercept an impervious clay layer. And if that impervious clay layer is not found through our geotechnical investigations, we'll be able to create an impervious layer by a grouting operation that would be utilized to improve the ground in those areas. So now I'm going to go through it's about a 4-minute video that's going to go through the construction sequence on the intake structures, and I'll narrate that as we go along. There's going to be a little bit of a warm-up here. But as you're aware, there's 3 intakes on the Sacramento River along adjacent to Highway 160 between Cortland and Clarksburg on the east side of the Sacramento River. We're going to focus on intake number 2 with this video. One of the first activities we'll be doing is clearing the sites and preparing those for construction activities. So the footprints that we've shown in the environmental documents show the approximate sites that we will be clearing. And then now this is the first series of slurry cutoff walls that will be installed as part of the project. You can see we excavate the material, put in a cementitious, and now you can see the ring of the slurry cutoff walls around the project site. Once those slurry walls are installed, then the dewatering wells can be installed within that enclosed area, and we can begin dewatering that site. As necessary, we'll be doing a ground improvement operation to inject grout into the ground to basically strengthen and stabilize that ground. And then the next activity will be to remove any of the unsuitable subsurface materials, particularly peats and other soft materials, in preparation for construction of the box conduits. These are the conduits that I showed you on that 3-dimensional diagram that will allow us to monitor and control the flows and evenly distribute it across the entire length of each of the intake structures. Now with this project, we'll be relocating a portion of Highway 160 at the intake structures. And so all of the work that we're doing up to this point is a predecessor to relocating Highway 160. Because in the present location of Highway 160 is where the intake structures will go. Once that relocation is completed, we will move the traffic onto the new portion. Now these are the first structural walls of the intake structures to be completed. They're called diaphragm walls, and the differentiation between those and slurry walls is that there's actually reinforcing steel installed in these walls with knockout panels that will allow us to connect the actual intake structure to the conduits that have already been constructed behind those. Then next we'll be installing the cofferdams along the Sacramento River, and this will allow us to isolate the work areas from the Sacramento River and then dewater that space between the cofferdam and the diaphragm cutoff wall. Once the sheet pile wall is installed, we'll be able to excavate that area, again do any ground improvement that we need to stabilize that ground, and begin constructing and installing the foundation piles. Now the exact method that these piles will be installed, they can either be driven piles or they can be cast in place piles. This will probably be a means and methods that will be determined by the construction contractors when they propose their bids on the job. Following the installation of the piles, the actual intake structure and distribution boxes will be constructed and the screens will be installed. And then finally, a series of collection conduits will be installed on the backside of the screen intakes. Again, ground improvement will be utilized as necessary. We'll be determining when ground improvement is necessary based on additional geotechnical investigations. Finally, we'll begin working on the land side of the intake structures, constructing the outlet shaft. This will connect to the tunnels. At a couple of the sites, this shaft may also be used to drive the tunnels from these locations. So we may have tunnel boring machines launching from this location and moving outwards towards the intermediate forebay. But again, these outlet structure shafts will be constructed within the previously constructed slurry walls, so there will not anticipated to be any impact on the surrounding groundwater levels. Finally, the construction of all of the remaining landside facilities will be completed, and then the cofferdam will be removed. Now we need to flood the inside of the cofferdam in order to be able to pull the sheet piles out. That's what you're seeing there. Once the sheet piles are removed, we'll be able to begin moving water in through the screens and into the outlet shaft. So that completes the kind of the overview of the construction activities plan for each of the intakes. So the next thing that I'd like to talk about is the existing water diversions. We've done field investigations. We've also looked at the state board records, and we've identified that there are 10 users of water that will be affected by our operations and construction at the intake. 10 of these will be temporarily affected by our construction activities, and 5 will be permanently affected. I'll also talk now about some of the mitigation measures for the temporarily affected. We are optimistic that we will be able to extend their existing piping from the river and relocate some of their pumps that provide water from the river without having to install new actual diversions at the river. So that will be our first option. Then secondly, if we're not able to do that, or for some of these temporarily affected diversions, we'll be installing new wells for them on a temporary basis, or providing them an alternate supply of water for their irrigation purposes. And then the mitigations for the permanently affected, we'll be going through the same temporary mitigation measures, but then if they're permanently affected, we'll be relocating their diversions outside of the intake structures themselves. And then, or if that is not possible, we will be providing them a turnout from the sedimentation basins located at the intake structures. So I'm going to go through each of the intakes, and you'll be able to see where these affected turnouts are located. At intake number 2, there's 6 total. 3 of them are permanent relocations that will have to take place because they fall right within the footprint of the intake structures. And then the remaining 3 are temporary relocations. You can see them in green. These are located where the Highway 160 relocation will take place. So our first, again, mode of mitigating these relocated temporary diversions would be to extend their existing infrastructure away from the project site and then reconnect their pumps and other infrastructure to allow them to continue to use their existing diversions. One of the things that we found out when we were researching this subject is there are several of these diversions were not in the state board's database, so we're going to have to do more investigations on those as far as whether they are actually legal users of water. At intake number 3, we have no permanent relocations. All of these are in the state database. These will be temporary relocations. And then moving on to intake number 5, there's 4 total. 2 of these will be permanent relocations. Again, both of these 2 were not within the state's database, so we'll have to do some more investigations on those. We have no information as to the amount or quantity of their diversions. Okay, I've got a couple short videos on the tunneling coming up, but what I wanted to do was sort of set the stage for those by giving you an explanation as to our plans for the main tunnels, but these would be representative of the north tunnels also. So there's 2 40-foot inside diameter tunnels. They'll be separated by about 90 feet. The size of the tunnel boring machines that will be utilized will be about 45 feet in diameter. They're relatively deep tunnels, about 150 feet deep. Again, we're expecting that the ground water level is virtually at the surface. So this is considered soft ground. We have silt, sands, and clays in various layers all the way through the ground. We have a peat layer at the top. In some areas, it's deeper than others. The water pressure, because it's fully saturated ground, is about 65 pounds per square inch at the bottom of the tunnel. So that's roughly what you might have at your garden hose, depending on the water pressure at your house. And it may not seem like very much, but when that water pressure is applied across the face of a 45-foot excavation, the forces there are very large. And if we were not able to successfully control those forces, as we opened up that tunnel for excavation, that ground would want to rush in and basically flood the tunnel and the tunnel boring machine. So the technology that we are planning to use is what they call a pressurized face tunnel boring machine. It means that the tunneling equipment itself will exert a counterforce with air pressure to basically resist the water pressure that wants to move the soil into the tunnel. And I think the video does a pretty good job of describing that. On the right-hand side of this slide, you can see the tunnel boring machine that was used recently for the Port of Miami. It was roughly the same size as the machines that we're proposing for this project. It was also a pressure-faced tunneling machine. These machines are used very commonly throughout the United States. In fact, a few years ago, SAC Regional Wastewater District used about a 12-foot diameter tunnel boring machine for one of their sewer tunnels. Other places like the Port of Miami, many of the metro tunnels that are done in Los Angeles, San Francisco, throughout the United States, the Seattle large SR 99 tunnel, in Washington, D.C., there's a number of these types of tunnels. Basically, this technology is pretty standard on a worldwide basis. So now what I'd like to do is move into two videos that will explain how these machines operate and specifically how they operate to control the ground in front of the machine in a controlled manner so that tunneling can take place successfully. And then the second video discusses how the tunnel will be constructed after the machine passes by. We are proposing to use what we call a concrete segmental liner. It will be a segmented liner that will be constructed in pieces with gaskets to allow us to eliminate water flow either out of the tunnel or into the tunnel. And you'll see a short video on how those are assembled. This is a narrated video, so there should be some sound with it.
With its rotating cutting wheel, the tunneling machine breaks the material from the tunnel face. The material is then transferred to the belt conveyor system in the rear of the shield via a screw conveyor, while the hydraulic cylinders press the machine forward continuously. The reinforced concrete segments, known as lining segments, are installed under the protection of the shield skin. When the ring building has been completed, the machine can push itself against the new tunnel ring and drill further into the soil. The working method of an EPB shield is basically made up of two phases, the tunneling phase and the ring building phase. During the tunneling phase, the cutting wheel, which rotates at a speed of up to 2.7 revolutions per minute, is pressed against the tunnel face with a pressure of up to 400 bar by means of hydraulic cylinders. 24 hydraulic motors drive the cutting wheel via a gear rim, developing a drilling torque of up to 38,000 kilonewton meters. Under this high pressure, the disc cutters and cutting knives made of high-strength steel loosen the material at the tunnel face. For shield tunneling in non-stable soils, a loss in stability at the tunnel face is compensated by creating a support pressure. In the case of the earth pressure balance shield, the soil which was excavated by the cutting wheel is used to support the tunnel face. In order to reach a state of equilibrium, the support pressure is transferred by the hydraulic cylinders via the bulkhead to the soil, which avoids an uncontrolled penetration.
That's it. Okay.
A complete tunnel ring consists of several segments, called lining segments. These prefabricated reinforced concrete elements are produced with millimeter precision in a factory which is especially installed above ground for this purpose. Following quality control, they are then transported into the tunnel by mine cars. In the front section of the backup, The lining segments are lifted individually by a special transfer crane. It lifts them onto the segment feeder, which transports the elements to the front of the tunnel. The positioning of the segments always follows the same routine. The erector lifts the stone from the segment feeder. The hydraulic cylinders are then retracted from the corresponding installation point. The segment is positioned precisely, holding site contact next to the previous installed ring, using a remote control. Now the hydraulic cylinders are extended again to secure the segment in its position and to subsequently bolt it into the previous ring. During this process, machine and tunneling personnel are protected by the shield skin against the earth pressure and any possible groundwater. In this way, the lining segments are installed on each side alternately. The key segment, with its tapered sides, is slotted into position last and distributes the loads in the ring, completing the ring building. Subsequently, the next tunneling phase can start. The end of the shield, the so-called tailskin, is equipped with a circular tailskin sealing. This provides a seal between the sealed structure of the shield machine and the segment ring. This in turn guarantees the necessary sealing between the interior working space and the exterior earth pressure. The remaining annular gap between the outer side of the lining segments and the soil is continuously filled with grout via injection holes in the tailskin or in the lining segment in order to provide a bed for the tunnel tube and to stabilize it.
Okay, I believe that's it for that video. Now we'll move on to another component of the tunneling activities, which deals with the shafts. There will be a number of tunnel shafts that will be constructed along the tunnel alignment. You saw the construction of one of those types of shafts at the intake structures. There will be a number of other shafts constructed, and these shafts will be used to either launch the tunneling operations, which is to start the tunneling operations, and then provide basically an access point into the tunnels for operational personnel of the tunneling, the construction crews, bringing in the lining segments, bringing out the reusable tunnel material or tunnel muck from the tunnels as the machines are excavating. And then also the second type of shafts that will be utilized, what we call retrieval shafts. At the end of the tunneling operations, the machines will be removed from the ground, so a shaft will be constructed at the end of the tunnel run, and the contractors will be able to remove their equipment from those shafts. At about the midpoint on the tunneling drives, now each of these tunnel drives is about 7.5 miles, so at about the midpoint, there will be what we call a vent shaft that will be constructed by the contractor. And these will be smaller shafts in diameter, but will allow the contractor to drive their tunneling machine into that shaft, and so under atmospheric conditions, so this will be open to the atmosphere at these shafts, they would be able to do maintenance work on their tunneling equipment. So you can see we've broken up the project into about these 7.5 mile reaches, and then each reach has been broken again in approximately half. So the tunnelers will be tunneling about 3 miles at a time before they get to a point where they can do maintenance on their equipment. Now they also have the ability to do maintenance in between those points by injecting grout down into the ground, stabilizing the ground, and then driving the tunneling machine into that location so they have a safe and secure location underground to work on their equipment. These shafts will be constructed with diaphragm walls in much the same manner that the slurry cutoff walls will be constructed. So as these shafts are constructed and put into operation, we do not believe there will be any impact on surrounding groundwater levels once the shafts are installed. They'll be installing a diaphragm steel wall with reinforcing steel, placing the concrete, and then removing or excavating the soil from inside the shaft and installing what we call a tremmy concrete bottom. This is a very large plug, about 30 feet deep, 30-foot thick plug of concrete at the bottom of the shafts, and that allows the shafts, again, to be watertight and also to decrease their buoyancy so they would not be uplifted by the uplift forces in the delta because of this saturated ground condition. Now we'll move on to the forebays and the embankments there. As I mentioned, we'll be using slurry wall construction in these embankments, again, so that we can isolate each of these forebay locations so that dewatering can take place inside the construction site without impacting any of the groundwater levels outside of that area. You can see the slurry wall in the center of the embankment levee. And then secondly, we'll be installing tow drains on the land side of these embankments, again, to collect any seepage water that may make its way through the embankment. The next slide here is just an aerial view of what we're envisioning the intermediate forebay to look like. At the top of the slide, you can see the two tunnels from the intakes arriving and delivering water to the intermediate forebay. The intermediate forebay is a collection point for water from the three intakes. It allows us to then split the water evenly between the two 40-foot tunnels, and you can see those are on the bottom left side. Those would be the 40-foot tunnels exiting the intermediate forebay. Next, we move on to Clifton Court. You can see on the left side, this is the existing Clifton Court with the old river intake kind of at the on the right side of that, and then you can see the Skinner Fish Facility is on the left side. On the right side of this panel now, you can see what we're proposing to construct with the California WaterFix. We've basically bifurcated the Clifton Court in half so that screened water is delivered to the north half, and then through a series of canals, that water is then brought down to the Jones and Banks pumping plants. We also have the south half of Clifton Court, which, as I mentioned earlier, we'll be expanding that to give DWR the operational volume of water that they need in order to continue on with their current style of operations. But the north and south Clifton Court will be designed and configured so that dual operation of Clifton Court could be utilized as needed by DWR. Finally, we get to the Clifton Court pumping plant. This is an aerial view. This is in the northeast corner of Clifton Court. The West Canal is at the top of that slide. At the bottom of the slide is actually the north part of Clifton Court. So the tunnels will arrive into the bottom of each of these pump stations. The water will well up, and we are utilizing vertical turbine pumps to lift the water from this location and deposit that into the north half of Clifton Court. So now I'm going to speak for a couple minutes about the head of Old River operable gate. This is the final portion of the WaterFix facilities. Again, it's located where the Old River splits off from the San Joaquin River. It's a location where DWR presently installs the rock barrier. You can see it here. As I mentioned, it's going to be a permanent facility constructed within the existing confines of the levees. There's going to be bottom hinge gates that can be either raised or lowered depending on conditions. There'll be a fish passage structure as well as a boat lock and some other miscellaneous facilities that go along with that. And again, it's going to be within the confines of the existing channel, so there's no levee relocations required with this facility. This is our artist rendering of that. You can see the operable gates in the center of the river, and then just to the kind of to the right of that, there's a boat passage and a fish lock. Flood protection will be taken into account at all of the aspects of the California WaterFix. At the intake sites in particular, we'll be required to obtain a Section 408 permit from the U.S. Army Corps of Engineers. So we'll be providing both temporary and long-term protection measures along the Sacramento River as these facilities are constructed. I've talked about a number of those as far as the use of the slurry walls. The elevations of all of the California WaterFix facilities will include elevations that will protect us from the 200-year storm plus sea level rise. And then in the surrounding levees that we'll be passing underneath, the non-core levees, it's our proposal to do a series of assessments of the existing conditions of those levees. We know that they're stable at this point, but as our tunneling equipment tunnels underneath there, we want to make sure that we fully understand the geology underneath each of these levees. We'll be providing improvements as necessary. So if some of the levees are deemed to be needing reinforcement before our tunneling passes underneath them, or before any of our construction equipment uses those levees for access roads, we'll be making improvements to those portions of the levees. And then finally, we'll be utilizing a monitoring program through all phases of construction to make sure that there's no deterioration of those levees. And that concludes my presentation. at this point in time. Thank you very much for this opportunity.
Thank you, Mr. Bernowski. Anything else, Mr. Mizell?
No, that concludes our direct testimony. At this point, the panel's available for cross-examination.
All right, thank you. We'll begin with group number 3, the state water contractors.
Stephanie Morris for the State Water Contractors. We don't have any cross-examination. Thank you.
Thank you, Ms. Morris. Group number 4. I don't think the microphone is on.
Sorry. Rebecca Aykroyd for San Luis and Delta Mendota Water Authority. We don't have any questions for cross-examination.
Thank you. Number 5, Westland.
Rebecca Harms on behalf of Westlands Water District. We have no questions for cross.
Thank you, Ms. Harms. Number 6, Coalition for a Sustainable Delta. He is not here. Group number 7, please.
Good morning, Chair Dodick, David Olajim for Sacramento Valley Water Users. Mr. Minarski, very nice to meet you. Thank you for testifying this morning.
Thank you.
Let me begin.
Mr. Olajim, could you get closer to the microphone? Thank you.
Can you hear me now? Okay. Mr. Minarski, you've headed up the engineering effort on the tunnel since about 2013, isn't that true?
That's correct.
Okay. And as such, you've been in charge of the redesign of the California WaterFix project as it has transitioned from the Bay Delta Conservation Plan through into its current configuration, right?
That's correct.
Good. And you were familiar with the many design constraints on the project. I think you mentioned that in your testimony this morning. Is that right?
There are constraints, yes.
You said in your resume that you were in charge of reconfiguring the river intakes, tunnels, and pumping systems to achieve budget, schedule, and environmental commitments for the program. Is that correct?
That's correct.
Could you identify for the board the chief constraints on the project as you redesigned it from the Bay Delta Conservation Plan to the California WaterFix?
Well, I believe that those were identified in my testimony.
Could you tell us where?
Sure. On page 4 of my testimony, I believe we begin to list out all of the numerous changes that have been made to the project over the last several years. Beginning at the bottom of page 4 of my testimony.
I'm just waiting for State Water Board staff to get that
Okay.
up here. I think we want DWR 57.
Yeah, DWR 57.
No, those are my prepared slides. We're looking for DWR 57 in the boards.
Page 4.
So, Mr. Benarski, you were
Yes.
about to say.
Yes. So starting on page 4 with a section called Engineering Refinements, I discussed the number of specific changes that were made to the project since 2013.
I see that, Mr. Benarski. It's not quite my question. My question was, what were the constraints that were imposed upon you and your engineering team in redesigning the project? Not what changes were made, but what direction for constraints you were given.
I'm not sure that I quite follow your question.
Let me re-ask the question. Did anyone from the department or the state contractors or Metropolitan, your employer, tell you these are the parameters we have to meet? These are the criteria we have to use in redesigning the project?
I would not say we received specific instruction. We were operating under the same general requirements that applied to the project previously. We knew that we were receiving input from a variety of sources, including public comments during that time. We wanted to be responsive to those public comments and adjust the project accordingly. We also recognized that with that, there were opportunities to make other revisions to the project that would improve its efficiency and flexibility of operations. So we took that opportunity to do that also. We also had a program budget that we needed to stay within. So all of these had to be worked together.
Let me drill down a little bit more. You identified that you received, or the department received, as I recall, tens of thousands of comments on the Bay Delta Conservation Plan. Isn't that right?
That's my understanding. I don't specifically know, but that's my understanding.
Did anyone from the department tell you, based upon the public comments we've received, we should redesign the project to do X, Y, or Z?
Yes.
What was that instruction?
We were asked to examine whether we could relocate certain facilities to move them from one area to another.
Could you be more specific?
Specifically, I mentioned this in my testimony. One of the facilities was the intermediate FOREBAY. It was.
Were there others?
The pumping facilities.
Anything else?
The alignment of the tunnels.
Anything else?
Those were the major ones that I can remember at this point in time.
Okay, let me move to slide 1, which is page 5 of your testimony. Thank you. Mr. Minarski, this is following up on the discussion we've just been having. You say here that specific changes to the project include, and then you list a number of these, which we've just begun to discuss. Were there any other major changes to the project?
I believe they've all been listed in my testimony.
Okay. In terms of the, let me start here with the bifurcation of Clifton Court FOREBAY. You indicated that the FOREBAY will now extend to the south. Is that correct?
That's correct.
Do you know, Mr. Minarski, who owns that land to the south?
I do not personally know. It's not owned by DWR.
Thank you. In terms of the tunnels, I had a question for you about their operation. You indicated that there's substantial, and correct me if I get this wrong, hydraulic pressure at 100 or 150 feet below the Earth's surface. And therefore, there needed to be air pressure to stabilize the tunnels. Is that correct?
I believe my testimony was that during construction there would need to be, yes.
Okay. Thank you for the clarification. After the tunnels are completed, Would there need to be that air pressure?
No, there would not.
Okay. Presumably, would the tunnels be filled with water at that point in time, and that would counteract the water pressure underneath the surface of the earth?
The design of the tunnel lining segments will counteract that effect. The tunnel can be empty and still be structurally sound and waterproof, so it does not rely on the water to do that.
Do you know, Mr. Benarski, whether the tunnels would be emptied during operation?
They would not be emptied when they're operational.
It wasn't quite my question. Do you know, in the proposed operation of this facility, whether the department anticipates that the tunnels would ever be empty?
Yes, they do.
When would that be, and under what conditions?
On some schedule, yet to be determined, the department would dewater the tunnels and do an inspection of those tunnels.
And would those inspections be annual, every 10 years, every month?
I do not believe that the frequency has been identified at this point in time.
Mr. Benarski, if I understand your resume correctly, you were in charge of Metropolitan's inland feeder project.
Yes.
Is that correct? Based on your professional experience, what would be a typical maintenance routine here?
Possibly every 10 years.
So the tunnels would be filled when, except for that interval every 10 years when maintenance and inspection would occur.
Based on my experience.
Thank you. You also mentioned the dual operation of the tunnels and Clifton Court FOREBAY. Would it be possible to operate both the North Delta diversion and the South Delta diversion at the same time?
I'm going to object to this. We're not on the operations testimony at this point in time. This is just the engineering.
Chair Duduk, I'm trying to understand the physical capacity of the facilities. He's the engineering expert, and I'm entitled to ask that question.
Thank you, Mr. Lajim. Please answer, Mr. Brunowski.
We've provided the capability that that type of operation can take place.
Thank you. Mr. Benarski, you're familiar with DWR Exhibit 212?
Yes.
Did you prepare that exhibit, or was it prepared under your direction?
It was prepared under my direction.
Were you in charge of ensuring that that exhibit met applicable engineering standards?
Yes.
Were there other key members of your team who participated in the development of DWR 212?
Yes, there were.
Could you identify them, sir?
There were many people. It would be a long list of which I'm not sure I recall all of the names.
That's fine. Would it be fair to say, if I had questions about DWR 212, that you're the proper person to ask?
You could start with me. Yes.
Thank you. Returning to page 5 of your testimony, you indicated that you believe these are the chief changes that were made in the project. Is that correct?
Yes.
Is there a complete list anywhere else in your testimony or in the department's exhibits that lists all the changes that were made from the BDCP to Clean Water Fix?
I believe that the recirculated EIR-EIS lists a number of these changes that we've made to the project. I'm not sure that it... Oh, sorry.
Excuse me.
Yeah.
I was going to say, can you identify where in the recirculated draft that would occur?
I'm trying to remember I'm Gwen Buchholz, and I'm trying to remember which chapter it is, if it was chapter 4 or 5, and I...
Ms. Buchholz, good morning. It's good to see you again. Madam Chair, I would be certainly happy to have that information provided at the break, just for the record. There's no reason to waste time here.
Thank you, Mr. Lodgem.
Mr. Benarski, could I direct your attention to DWR page 212, Exhibit 212, page 66. That should be the second slide. And you're familiar with this exhibit, correct?
Yes, I am.
Want to direct your attention down, if you could move the slide down there, a bit further. There we go. Section 4.4.1, operating assumptions. Do you see that, Mr. Benarski?
Yes, I do.
Okay. The first bullet there reads, as an operating assumption, to operate safely and reliably, complying with all applicable regulations, including all long-term Delta operating rules developed by the BDCP. Would it be fair to revise that statement to say all operating rules developed by the department?
Objection as to who you're referring to as the department.
The Department of Water Resources, excuse me.
It's my understanding DWR will be the operator of these facilities. So if that is the case, then I would say yes.
Thank you. Let me direct your attention to the fourth bullet, which says minimize impacts to the established operational methodology and control philosophy of both the SWP and the CVP downstream of their respective existing export pumping plants. Do you see that?
Yes.
Mr. Benarski, can you describe what you meant by operational methodology and control philosophy?
We are providing water through these facilities that will match the hydraulic gradients that go into the existing pumping facilities.
So if I could understand this correctly, when you minimize impacts, you are trying to maintain that hydraulic gradient. Is that correct?
We are trying to maintain the existing hydraulic gradient to those pumping facilities.
Thank you very much. That's helpful. Let's move on to the next slide, which is the next page of DWR 212. And let me direct your attention, Mr. Benarski, to table 4-6, which is entitled Daily Operational Considerations for Withdrawal from the Sacramento River. Do you see that, sir?
Yes, I do.
I've highlighted on the slide here a factor that is hydrological. And the first comment there is limitations on volume available for export based on flow rate within the Sacramento River per BDCP. Do you see that, sir?
Yes.
Again, can we substitute per BDCP for the Department of Water Resources?
Consistent with my previous response, I would say yes.
Okay. Can you explain, sir, limitations on volume available for export based on flow rate within the Sacramento River? Does that mean that exports would be limited to some percentage of the flow rate in the Sacramento River, presumably at the intakes?
It's my understanding that flow rates through the intakes will be limited based on the volume of water in the Sacramento River at any time. Flow rates in the Sacramento River, not volume of water. I'm sorry, I misspoke.
So if there is X CFS in the Sacramento River at the intakes, then there is some percentage of that that would be available for diversion at the intakes. Is that correct?
It's my understanding that there will be guidelines set for the operation that will limit the amount that can be diverted based on the flow rate in the Sacramento River.
Would it be correct, Mr. Benarski, from your previous answer to say that those guidelines have not been established?
I'm going to object to being speculative on his part. He's an engineer for the facilities design, not the operations panel, which is going to discuss the operational criteria that we're setting forth.
And Chair Doduk, as an engineer, he's given criteria to which he is designing this facility. And I think I'm entitled to know what percentage of flow he's designing this facility to divert.
I would agree he is perfectly equipped to answer design specification questions, but not operations questions.
I believe the question from Mr. Alajim was whether those operational criteria has been provided to him.
That is correct.
And on that basis, he may answer.
Those operational criteria have not been provided to us.
So, Mr. Benarski, let me see if I understand this. You understand that the intakes are going to divert a certain, let's use a percentage, because I'm not technically able to say anything else, of the flow in the Sacramento River. You have not been provided the operational criteria. How do you design a facility like that?
Our design is presently based on the elevation of the water in the Sacramento River. And our design criteria was to allow 3,000 CFS of diversion at different water level elevations in the Sacramento River.
So let me see if I understand what you just said. At different water stage in the Sacramento River, you have designed a facility so that it can always divert at each of the intakes 3,000 CFS. Is that?
Objection misstates the witness's testimony. He didn't say always, and he didn't say an amount.
Mr. Alajim, please
I am trying, Chair Doduk, to accurately state, and I'm looking for a correction from the witness. Let me try that again. Is the facility designed so that it can divert at each of the intakes 3,000 CFS under differing stages of water in the Sacramento River?
Yes.
Thank you. Let me move along to the system mode of operation. One of the comments there is Water Right Decision 1641 and subsequent amendments. What did you mean by that, Mr. Benarski?
Operations of the system by DWR would be consistent with that decision 1641.
But Mr. Benarski, decision 1641 did not contemplate North Delta diversions, did it?
I am not personally knowledgeable of decision D 1641.
Thank you. Let's move along to the bottom of that page. You indicate here, the BDCP is expected to include long-term water operation rules for the Delta, including North Delta diversion bypass rules, representing the minimum flow to be maintained in the Sacramento River downstream of any diversion intake location. Do you see that, sir?
Yes, I do.
Has the department developed those long-term water operating rules for the Delta?
I do not know.
Would there be other design constraints on the intake structures besides the ones that are listed here in Table 4-6?
Can we see Table 4-6?
Oh, I'm sorry. Can we go? Scroll down, please.
Could you repeat your question, please?
Sure. Would there be any other design constraints that you used to develop the intake design other than these criteria in Table 4-6?
Objection misstates the evidence. These are design considerations, not constraints or criteria.
I'll accept the correction. Mr. Bernarski,
Same
could you ask-
question?
Yes.
Yes, I believe in my testimony and in the presentation, I gave a list of criteria that were given to the design team through the work of the Fish Facilities Technical Team that prescribed some additional design criteria for the intakes.
Very good. Let's continue on then with the next slide. And thank you for the transition to the Fish Facilities Technical Team. This slide should be DWR 57, page 9. Mr. Bednarski, have you, do you have that in front of you?
Yes, I do.
So you said in your testimony that site selection included, in no particular order, a number of different factors here. The site's ability to minimize effects to aquatic and terrestrial species, maintain a diversion structure's functionality, provide adequate river depth, provide adequate sweeping flows, and minimize effects to land use and community. And also maintain flood neutrality. Is that correct?
Yes.
Were those, in combination with Table 4-6, the considerations that you used in designing the intake facilities?
The criteria, yes, we received this input from the Fish Facilities Technical Team that took into account these parameters when they cited the location of the intakes and gave those locations to us.
Let me follow up on that, sir. The Fish Facilities team identified the locations for the intakes. Is that correct?
Yes.
Could you describe how that process occurred?
I was not involved in that process.
Who would know how that process occurred, sir?
I'm a little bit familiar with it, but this is Sergio Valles, Metropolitan. There was a group of 5 agencies that got together, and that was NIMS, the Fish and Wildlife, Fish and Game, DWR, and the Bureau. And they jointly worked together to determine the best location for the facilities.
And so, first of all, good morning.
Good morning.
Would it be correct to say that that fish facilities team was composed primarily of biologists rather than engineers?
I believe they actually did have engineers involved.
Do you know who was involved either for the DWR or for the Bureau of Reclamation as an engineer?
I do not know, or do not recall, let me put it that way.
As part of that evaluation of these intake locations and the design of the intake, did DWR consider potential water quality effects either upstream or downstream of the intakes?
Can we object to speculative and also a portion for part 2? The Fish Facilities Technical Team is something we will discuss in part 2 because it is primarily a biologically based decision, and whether or not it included water quality, we can certainly discuss it at that time. These engineers, though, have indicated they're not part of that team, and it would be speculative on their part to presume what was discussed.
Chair Doda, first of all, this is a question about DWR, and we have the department here. Second of all is a question about the engineering criteria. Third, in terms of water quality, an injury to a legal user of water can be a decrement or a degradation of water quality. All of this is fair game right now.
Then I would
Okay.
object as asked and answered because they've already discussed that they have received the output of the facilities technical team and used that in their design.
Chair Dodek.
Mr. Lodum, you don't have to continue. I'm going to allow you to ask your question.
Thank you.
And ask the witnesses to answer to the best of your ability. And if your answer is to defer to the witnesses to come, you may do that as well. But these witnesses may not be back, so Mr. Lodum, you may ask your questions.
I'm not aware of the what criteria they use specifically. For us, the important criteria is the 0.2 feet per second approach velocity. That's how we size the intakes.
Very good. Thank you. Mr. Minarski, let's move to the next slide, which is DWR 57, page 2. You say here, beginning on line 4, construction impacts having the potential to affect other users of water are generally limited to potential impacts of existing water supply facilities and potential impacts to groundwater level. Isn't that right?
That's correct.
So if the project were to change water levels in the delta, that would not be a construction-related impact. Am I understanding your testimony?
That's correct. This sentence only refers to construction impacts.
Okay. So in terms of water level impacts, would those questions be properly addressed to Mr. Lehigh?
Possibly.
Should I address them to you?
No, I would not be able to answer those questions.
And as the engineering manager for this project, are you aware of who else would have technical knowledge about water level impacts in the delta from this project?
Can you be more specific about where the water levels are that you're referring to?
In the vicinity of the intakes first.
So along the Sacramento River?
Yes.
I believe that could be either Mr. Lehigh or the modeling team.
Okay. And more generally in the delta?
The same.
Thank you. Similar question about water quality. Would Mr. Lehigh be the appropriate person to ask questions about water quality effects of the project in the vicinity of the intakes?
Yes, or the modeling team.
Thank you. If I could direct your attention further down that page, lines 13 and 14, you say no adverse water quality effects to beneficial uses from construction-related activities would occur. And earlier in that paragraph, you make reference to an NPDES permit and various BMPs, best management practices. Is that correct?
That's correct.
Could you describe what BMPs are being considered here to address the potential construction-related impacts of the project?
If I may, Madam Chair, the BMPs associated with this NPDES permit for stormwater discharges and non-stormwater discharges are presented in Appendix 3B of the draft EIR, draft EIS, and in detail. We could read them if necessary, but they're in Appendix 3B.
Mr. Lodgem,
Thank you.
would you like her to expand, or are you satisfied with that?
I will again take a reference from Ms. Buchholz after the end of the cross-examination as to the specific page.
Thank you.
But following on Ms. Buchholz, since we don't have those quite in front of us today, has the department developed a mitigation monitoring and reporting program for those BMPs?
Not at that time, but they have made the commitment in Appendix 3B to prepare one.
And Ms. Buchholz, you have extensive experience as an environmental consultant, isn't that correct?
I have experience over many years as such.
You're too modest. Would the reporting of those BMPs be directed to the State Water Board or other regulatory agencies? And if so, could you identify the likely agencies? Obviously, since you haven't written the MMRP, you don't know for don't know exactly.
Associated with water quality?
Yes.
Okay. The water quality certainly would go, in this case, it could go through the Central Valley Regional Water Quality Control Board and therefore under the State Water Resources Control Board. It would also potentially be considered by some of the counties based as we've described in the Chapter 8 of the Draft EIR, Draft EIS, and Recirculated Draft EIR, Supplemental Draft EIS, and Appendix 3B.
Next slide, please.
Mr. Olajim?
Yes.
Before you move on to your next slide and next topic, do you anticipate your cross-examination to take additional time? I'm looking at the court report. I want to take a short break for her and for all of us.
Chair Dodek, this is sort of in the middle of my cross, so I think this would be a good opportunity for a break.
So let's do that. And we will reconvene at 10:45.
No, I agree.
All right. It is 10:45, and before we begin, Mr. Mizell, I believe you have a scheduling question?
Just a scheduling question,
Okay.
yes, Hearing Officer Dodek. And it may be out of an overabundance of optimism, but is there any expectation that we would need the operations panel here today, or are we pretty confident that that will take place starting next week? 'Cause
I'm
we didn't
confident
bring
that
them.
will take place next week.
Excellent.
Even the best case of optimism, if we do finish all the cross-examination, redirect, and recross of this panel today, I don't think anyone will object to leaving a bit early on a Friday afternoon. So I think it's safe to say next week.
Very good. Then we'll let him continue with his job and not attend this afternoon.
I'm sorry, what was that?
John Lehigh, we'll let him continue to operate the project, and we won't bring John Lehigh in to the audience with the expectation that he might present today.
Thank you, Mr. Mizell. Mr. Lodgem, please continue.
Thank you, Chair Dodek. Mr. Winarski, welcome back.
Thank you.
Let me address a question that you identified during your direct testimony, sir. Do you recall the animation that you showed this morning?
Yes.
As part of that animation, you showed a cofferdam being built out into the Sacramento River for the intakes. Do you recall that?
Yes.
Can you tell us how far the cofferdam would extend into the Sacramento River?
I don't recall the specifics of that.
Do you recall approximately?
Approximately 50 to 80 feet.
Did the department in your engineering development of the California WaterFix analyze the effects of that encroachment into the Sacramento River on water stage immediately adjacent to the intakes?
I believe we did, yes.
What was the result of that analysis?
I believe it was less than 0.1 foot, 0.1 of a foot, so about a little bit more than an inch.
Thank you, sir. Mr. Benarski, let me direct your attention to page 14 of your testimony, which I think is now up here on the screen. Yes, it is. At lines 21 through 23, you talk about the department determining current use of existing diversions, et cetera. Would that apply to diversions that are licensed or permitted by the State Water Resource Control Board?
Yes, it would.
Could you expand on what the department would do as part of that evaluation?
We would determine the amounts of the water diverted, the patterns of that diversion, and also the water quality of that water that's diverted.
And you would presumably rely as part of that analysis on the records of the State Water Resources Control Board?
Yes, if those are available, we would, yes.
Next slide. The top of page 15 of your testimony, sir, the first bullet, you say the department may assist in securing permits, and I presume it's well design, or will design, excuse me. Could you describe what the department's intent is with this provision?
Yes, the department's intent with all of these relocations is to make the diverter whole in all manners for these temporary diversions. So we will secure the permits, the materials, implement the construction of those facilities that are required as part of the project, and pay for, as it says, the implementation of these mitigation measures.
Thank you, sir. Page 19 of your testimony, next slide. You indicate that implementation and mitigation measures will include relocation or relocating and replacing agricultural infrastructure, et cetera, and that the process would follow the same framework as relocating water diversions. Do you see that testimony?
Yes, I do.
And your previous answer about assisting in securing permits, paying for those permits, et cetera, would that apply here to agricultural canals as well?
Yes, it would.
Next slide, page 12 and 13 of your testimony, sir. You say at the bottom, lines 27 and 28 of page 12, the channel margin habitat will be sited to avoid existing riverbank structures such as water diversions, and therefore construction of channel margin habitat will not displace existing water diversions. Do you see that, sir?
Yes, I do.
Could you explain to us, will the department simply avoid the areas around existing intakes for the location of channel margin habitat?
We will avoid them. Yes, we will.
And would there be some distance between each of the diversions and the new habitat?
Yes, I believe it's 200 feet.
Okay. If another regulatory agency, say for instance the Department of Fish and Wildlife, were to say that those diversions had an effect on the channel margin habitat that would be installed, what would the department do, if anything, about that requirement?
We would modify the location of the channel margin habitat so that it's consistent with those requirements. And
if the United States Army Corps of Engineers or the California Flood Protection Board were to require a levee district to riprap an area around one of those diversions, presumably the department would again move the channel margin habitat?
I'm not quite sure I follow your question as to the need to riprap around a diversion and how that would relate.
Let me try it this way.
Sure.
If a regulatory agency like the California Central Valley Flood Protection Board were to require riprapping an area to protect levee stability that had been identified for channel margin habitat, presumably the department would move the channel margin habitat.
Yes, that is correct.
Thank you. Mr. Benarski, the third portion of your testimony related to flood control impacts, correct?
Yes.
I'd like to direct your attention to page 9 of DWR 66. The testimony of Mr. Nader Tirani, I believe is the pronunciation. Are you familiar with this exhibit, sir?
No, I'm not.
Okay. And let's a question for Mr. Mizell. Will Mr. Tirani be a part of the operations panel?
No, he will be a part of the modeling panel, which is
Modeling? Okay.
modeling, yes.
Thank you. So, Mr. Bednarski, do you know whether the department has modeled the effects of the WaterFix project on water levels adjacent to the diversions? I seem to recall earlier this morning you said that it had.
I think you'll have to ask the modeling group for that.
Mr. Bednarski, you indicated in your testimony this morning that the department would file a Section 408 permit with the Corps of Engineers, correct?
That's correct.
Can you tell us what the status of that application is, sir?
I don't know at the present time the status of that. I'm not involved in that permit process.
Can you tell us whether the engineering group that you had was given any instruction about design criteria that would be necessary for the issuance of a 408 permit?
I don't recall whether we...
Let's turn back to a more direct construction discussion, Mr. Bednarski. You said early on this morning that the redesign of the project would reduce a number of the elements of the project in terms of the amount of concrete, the number of pilings, et cetera. Is that correct?
Yes, at the intakes.
Can you tell us the reduction, roughly, in the quantity of concrete, the number of pile driving strikes, the other operational parameters of that construction?
Objection, compound question.
Mr. Elijah?
Well, let me rephrase. Can you tell us how many piles the department is proposing to drive as part of the construction of the intakes?
Yes, there's actually a table in the CER that actually shows you that. I think there's like 1,110 piles for the long intakes being 1667.
And sir, for each of those piles, can you tell us approximately how many times that they have to be driven into place?
Object is speculative.
If he's an engineering expert, this is part of what is within his knowledge. If he can't answer, he can obviously not answer.
Mr. Bednarski or Mr. Vallis?
It's a really difficult question to answer because it's totally dependent on the type of soil that you're driving in, and right now we don't have a lot of geotechnical information. But right now the plan is to use vibration to drive the piles, and the last 30% of the piles will actually try to strike them into place to set them.
Thank you. That's very helpful. And sir, you just talked about the geotechnical investigation. There's an extensive memorandum, I believe, from Ms. Buchholz on geotechnical investigation going to groundwater effects. Would it be fair to infer from your answer just now that you don't have that same level of detail as to the soils at the location of the intakes?
We have a few borings on the river side where we had access to the site, but we don't have much information on the land side where we didn't have access to the property at the time.
Thank you. Mr. Benarski, on page 26 of your testimony and continuing to page 27, you talk about the evaluation of haul routes. I believe this is right near the end of my slides. Perhaps the last slide. Yeah, 26 and 27. So the department is committed to evaluating and improving all the haul routes for the construction of the intake facilities in California WaterFix generally. Is that right?
No, it's not.
Could you then clarify what the department is planning to do to evaluate haul routes and improve them when necessary?
As stated in the testimony, we're committed to carrying out necessary improvements on affected levee sections that would avoid potential deficient levee sections. So we will be identifying any sections that are deficient for the proposed or envisioned operations, and we'll be improving those sections only.
And to what level would you improve those sections, sir?
To improve them to the point that they are consistent with the type of construction activities that we would anticipate on those sections.
So, if a section were to be used as part of the haul route, and it was anticipated that there would be X number of trucks per day, the section would be improved to a standard that would allow for that traffic to be carried successfully, correct?
It would be improved if, through the field investigations, it was determined that it could not otherwise carry that traffic without improvements.
And those improvements would include both the stability of the levee as well as the height of the levee?
Stability as it would pertain to potential impacts from truck traffic, yes. Height of the levee, to the extent that our truck traffic would cause some subsidence from the settlement or something like that, yes. We would return it to its original elevation.
And speaking of elevations, you indicated in your testimony this morning that the intake structure would be elevated to the level of a 200-year flood, including sea level rise. Is that correct?
That's correct.
Has the department determined what elevation and mean sea level that would be?
At the intake locations, it raises the current level by about 6 feet.
About 6 feet, thank you. In analyzing the engineering criteria or developing the engineering criteria, excuse me, did the department consider the stability and flood protection provided by levees that would be adjacent to the site but not part of the facility?
It was not our plan to redo all the levees in the area other than the location affected by the intakes.
Thank you. That wasn't quite my question. Let's assume for the sake of discussion that the levees in areas adjacent to the intake facilities have 100-year protection. And let's assume that the new facilities have 200-year protection. It's possible that a flood of more than 100 years, but less than 200 years, would involve the inundation of areas around the intake. Isn't that correct?
Yes, that's correct.
Could you tell me, Mr. Benarski, what design features of the intake facilities have been developed to protect those facilities as against that situation?
Yes, the levees and the intake structures within the footprint of our activities have all been raised to that elevation, as have the levees and embankments and elevated pads that house the sedimentation basins, the sediment drying basins, and any of the other support equipment that we have to operate the intakes. Those are all set at that 200-year flood level plus sea level rise.
Chair Dodek, if I might have just one moment to review my notes.
Go ahead, Mr. Elijah.
Chair Dodo, no further questions.
Thank you, Mr. Elijah. I believe Group 7, Mr. Aaron Ferguson would also like to conduct cross-examination as part of Group 7.
Good morning.
Morning, Mr. Bednarski. I'm Aaron Ferguson, representing the Sacramento County Water Agency. I'm going to ask you a few questions related to potential construction impacts on local facilities that Sac County Water Agency manages.
Mr. Ferguson, you need to get closer to the microphone, please.
So on page 2 of your testimony, you indicate that construction impacts having the potential to affect other legal users of water are limited to impacts to existing water supply facilities and groundwater levels. And those are the sorts of impacts that you analyzed in your testimony. Is that correct?
That's correct.
And as part of that analysis, you analyzed whether there are impacts on various surface water diversions and agricultural canals, as well as potential impacts on groundwater in and around the facilities. Is that correct?
That's correct.
Did the engineering team analyze any potential construction impacts to existing groundwater production facilities that may be in the path or in and around the various WaterFix facilities, such as the intake or the tunnels?
If I may, when Buchholz. We didn't We weren't able to obtain the well logs from private wells, whether they were agricultural or potable water wells. We used some very regional information to indicate the trending of how many wells might be in the area that was prepared by previous studies by the Department of Water Resources. And in the environmental impact report, draft environmental impact report, draft environmental impact statement, and the recirculated draft EIR and supplemental draft EIS, we indicate that the very first thing that will be done during the design phases is to obtain detailed information on those wells. And in light of that knowledge that we know that there could be in the area, but we don't know the specific locations, we included mitigation measures to reduce the effects of construction and operations of the WaterFix facilities on those wells to a level of less than significance.
So would that potentially...
Hold on, Mr. Ferguson. I'm being annoyed by someone's phone. This is why I say check and recheck. Mr. Ferguson, please continue. Thank you.
So, Ms. Buchholz, in terms of the mitigation, would that include potential impacts? I think I understand some of the mitigation in the environmental documents concerns impacts to perhaps the agricultural wells in and around the intakes. Is that correct?
That's included, and that's referenced in Chapter 14 of the environmental documents.
Would the mitigation potentially include any impacts to, say, municipal wells found in and around the path of the proposed facilities?
The municipal or individual private potable water wells, as well as agricultural wells, are addressed in Chapter 7, as well as Chapter 14 for the agricultural facilities.
Okay. Okay. I'd like to talk a little bit about Reach 2 of the intake tunnel. The tunnel that, correct me if I'm wrong, it's the tunnel reach that extends from intake 3 to the intermediate FOREBAY. Is that correct?
Yes, it is.
And your testimony indicates that what are called the inverts for the north tunnels are projected to be at around 122 to 135 feet below mean sea level. Is that correct?
That's correct.
Roughly. And the invert is the bottom of the tunnel. Is that correct?
That's right.
Okay. Okay.
The inside bottom.
Okay. I have a slide, one of the map book slides. Can we go ahead and bring that up? This is a map book from the revised environmental document. And can you please turn to sheet 1, I think it's called. Continue down. So can we stop right there? So I just want to be clear, we're talking about Reach 2 extends out of the bottom of intake 3 there. Is that correct?
That's correct.
Now can we slide down to the next slide, please? And stop. Actually, can you go up, please? It's a little hard to read. Can you scroll up a little bit, please? But that is Reach 2 continuing there from the previous slide. Is that right?
Yes, it is.
Okay. And is it at the top there? It's a little hard to read, but does it pass through the town of Hood?
Yes, it does.
Or underneath the town of
Yes.
Hood? Okay. Thank you. So are you aware of the existence of 2 drinking water supply wells that the Sacramento County Water Agency uses to provide drinking water in the town of Hood?
I am not.
I'd like to focus in a little bit on these wells and the potential relationship between these wells and the tunnels. So can you please go ahead and bring up the next and I'm going to want to, I'll explain what's in this. I'm going to want to mark this as SCWA Exhibit 1. And there's 2 pages to it. So the first slide, what the engineers at the agency did was do their best to look at Reach 2, as is explained in the map book, and then try to plot it across the town of Hood in order to get a sense of the relationship between the location of the tunnel, the proposed tunnel, and the existing drinking water wells. So you'll see on the left side of the screen, the agency's well 19, that's their, called their 3rd Street well, is approximately 410 feet to the west of where the tunnel is proposed to be located, and approximately 185 feet east is their well 20. So my first question to you, does the alignment of the tunnel in this area, the WaterFix tunnel, roughly coincide with your understanding of where it would the surface features it would cross under, or pass under approximately 4th Street?
Yes, I believe it does.
Okay, thank you. Can you please go to the slide down to the next slide? The engineers as well have also prepared a cross section just to try to present a relationship between where the tunnel would lie, recognizing that the invert elevation will be could be within a range of 120 to 135 feet. And you see the 2 potential elevations of the tunnel there in the middle, and then the relationship to the 2 wells. And the well 19 is at an open hole well at 192 feet below ground, and then the well 20 has a screen at about 122 feet, and then I believe it has some additional well that are lower. So now I understood you to say that you weren't aware of the existence of these wells. Is that correct?
I was not.
Okay. So as part of the engineering team analysis, there was no analysis of whether the WaterFix construction and operation activities could, say, impact the physical integrity of these wells or the aquifer in and around these wells. Is that correct?
Objection misstates the testimony. Ms. Buchholz provided where analysis was provided.
Mr. Ferguson asked if a certain analysis was done. I believe Mr. Bernowski could answer that question.
Not on these specific wells. No, I don't believe there was an analysis done.
Okay. So in your opinion, you spoke a lot, you spoke a lot about the proposed boring technology and approach that's going to be used. Could the proposed tunnel boring approach, say, in your opinion, potentially disrupt the physical integrity of these wells, given their proximity to the tunnel?
No.
Does the WaterFix, and perhaps I've heard the answer from Ms. Buchholz, but I just want to be sure I heard it correctly, but is there a monitoring strategy to ensure that the integrity of wells like these are not compromised during the boring process?
That's part of our mitigation measures, yes.
Okay, and you indicated that that's in the groundwater section of the EIR?
It's in Chapter 7, Chapter 14, and Chapter 20.
I'd like to talk a little bit about your testimony regarding the tunnel boring machines and the approach to that tunneling. So you indicate that the proper use of the machines greatly reduces the potential for over-excavation. I'm sorry, the earth pressure balance machines greatly reduces the potential for over-excavation and resulting surface settlement. Is that correct?
That's correct.
So there is the potential for some surface settlement through this process?
If the equipment is not operated properly and monitoring is not conducted, there is the potential.
So in your opinion, if there were to be surface settlement in and around the ground level above the boring machine, could that impact the physical integrity of wells such as these?
Objection vague. Where would the surface settlement occur? And
So if there were surface settlement, it's not real specific in the testimony, so I'm not clear either, but if there were surface settlement as a result of the tunnel boring, would it occur above the surface of the tunneling machine?
Most likely. Yes.
Okay. So if that were to occur above the surface of the tunneling machine, with these sorts of spatial relationships with these municipal wells, could that have an impact on the integrity of these facilities?
I don't believe so.
In your opinion, could it cause groundwater well hole movement, do you believe?
I don't believe so.
Do you know whether the surface settlement could cause any change in the aquifer production characteristics?
I'm sorry, could you repeat your question?
Could any settlement caused by potential over-excavation, which is I explained in your testimony, result in any effects on the aquifer that serves these wells in such a way that it could, say, adversely change the aquifer production yield?
I guess if I could restate the question so I understand it. First of all, I think the surface settlement would be different. This is a different settlement than occurs when we have an overdraft in groundwater and causes regional land subsidence. This is something that would happen at the construction area above the area if the equipment was not operated correctly and monitored correctly. So I don't believe that this would change anything and cause subsidence and compaction of the aquifer hydrogeological conditions. And again, mitigation measures would require monitoring for production at all the wells in the vicinity of the construction. And this would be especially on well number 20, which would be relatively close. Well number 9, West 19 or W19 would not be as close.
Okay, so I just heard you just say, Ms. Buchholz, that there will be monitoring occurring in wells like these for their production yield.
Right.
I assume what's starting before the WaterFix tunneling and then during and then after to understand whether there's been an effect?
Right. The proximity between the well and the construction zone, that criteria has not been determined yet.
Okay. So when you say that criteria has not been determined yet, that means that must mean there are no thresholds for determining potential impacts.
At this point in time, no, there's not a quantitative threshold, and that would become part of the mitigation and monitoring report that still has to be prepared.
Thank you. I'd like to talk briefly about the tunnel lining system. Mr. Bednarski, you indicate that the tunnel lining system and methodologies will minimize potential effects to groundwater during construction and operation. So please correct me if I'm wrong, but are you acknowledging there could be effects to groundwater during construction and operation of the tunnels? As it relates to the presence of the tunnels in the ground and the tunnel lining system that will be employed?
We do not believe there'll be any impacts to the groundwater regime during construction.
What potential effects might there be during construction?
objection vague. Can you clarify what type of impacts you're looking for?
Could there be potential dewatering effects as a result of, say, the lack of integrity of the tunnel lining system?
No, there will not be. The tunnel lining system is multifaceted. There is the segments with the gaskets that will go into compression once the segments are lined, and then there's an annular grouting that is placed around that outside of the segments to seal it. So we do not believe there will be any impact on the groundwater.
So will there be a monitoring plan in place over time to assess the performance of that tunnel lining system and whether there could be impacts on the aquifer as a result of leakage or potential dewatering?
I believe there would be.
Okay, thank you. I'd like to talk a little bit about groundwater flow and potential groundwater surface water interaction in and around the areas of the river where the intake tunnels will be located. Particularly interested in Reach 2, but I'll ask more generally perhaps. So Reach 2 of the tunnel will be about 40 feet in diameter, is that correct?
That's correct.
Okay. And it'll Reach 2 in particular will run about 6 3/4 miles from the intake to the intermediate forebay.
Yes.
Okay. At an elevation again of about 122 feet below mean sea level.
Yes.
Okay. So that's a substantial structure, correct?
Yes.
So could a tunnel of that size in this location along the Sacramento River have an impact on the surface water groundwater interaction or change the surface water groundwater interaction in any manner?
When we looked at the available geotechnical investigations in this area and coupled that with the information that was compiled by the United States Geological Survey, and if I could observe from your exhibit here that's up right now on figure SCWA1-1, the tunnel would be to the left of that figure. If I've got this oriented right, I believe the left is the riverside. Yes. of the map. So we see groundwater recharge in this area to the wells, both, especially in the area of Hood, both from the east, from the east coming off the mountains and groundwater direction towards the river. And we also see groundwater recharge from the river back towards the land side. We don't believe that the structure, as you can see in the red circles where they're dashed or dotted, or solid or dotted, would impede the overall recharge or the production rates of these wells at these kind of depths, because the geology appears to be interbedded layers of sand and clays and silty sands, and clay lands, or silty clays. So we believe that the recharge would continue and that tunnel structure would not affect recharge of those wells.
Okay, thank you, Ms. Buchholz. I'd like to talk real briefly about the intakes and the same issue, the surface water groundwater interaction and groundwater recharge. So my understanding is the intakes will range in length from about 1,259 feet to 667 feet, correct?
Correct.
And there will be slurry cutoff walls around these facilities, correct?
Correct.
And I believe from DWR 218, which Ms. Buchholz prepared, it indicates that the slurry walls may be as deep as 150 feet. Is that accurate?
I believe that's correct.
Okay. So my understanding from the testimony is that the slurry walls are used to address issues of potential dewatering of the surrounding aquifer. Is that correct? As well as potential seepage from the sedimentation basins into those aquifers as well.
Yeah, those slurry walls basically protect both sides of the wall.
So did the engineering team, real quickly, just affirming again, Ms. Buchholz, I believe your testimony you indicated, and this is DWR 218, you indicated that in and around the intakes, water generally flowed from the river to the east. Is that correct? Into the basin?
It depends on each intake. Some of the intakes, I think it's intake, the first, most northerly intake has surface water around both sides of it. But primarily in the areas adjacent to the river, you'll see water migrating from the river, if it's high enough, in towards the recharge of the groundwater wells, especially if they're at these depths.
So did the engineering team analyze the potential impacts to groundwater recharge associated with these 3, 1,000+ foot barriers essentially to the and analyze the potential impacts of these on groundwater recharge in the area?
We use the United States Geological Survey Central Valley Hydrogeologic Model to look at regional trends of moving of water that would be removed because of the intake locations. We believe that the slurry walls now and that was considering a slurry or the diaphragm wall along the levee road. We believe that with the slurry walls surrounding the entire site, that the groundwater would still move around this structure because the aquifer is so much larger than the areas that will be occluded by the slurry walls. And we believe that, but at the same time, we would continue, as I said, as we've said in Chapter 7 and 14 and 20, that we would put in a monitoring program for wells that would be considered close, but that distance hasn't been determined yet. It will be in the mitigation and monitoring and reporting plan.
Okay, you were focused on particular wells, Ms. Buchholz. Is there any broader analysis of, and maybe you said this, but any broader analysis of impacts to the aquifer, the subbasin itself, and
the actual modeling in the that's presented in Chapter 7 of the draft EIR supplemental or draft EI draft EIS was actually much more of a regional aquifer recharge and effects on the regional aquifer than it was on individual wells.
I have no further questions. I would, if I might, if it's the appropriate time, to request that these 2 exhibits be moved into the record.
Thank you, Mr. Ferguson. I think I'm going to request that all exhibits used for cross-examination be identified, but then let's wait until the completion of all the panels and all the cross-examination before moving them into the record. All right. We will now move into group number 8, Tehama-Colosa Canal Authority. No one's here from group 8. Group 9, North Delta Water Agency. Mr. O'Brien is coming up.
Good morning, members of the board and staff, members of the panel. If we could pull up the PowerPoint, which is DWR2, page 19, please. Mr. Bednarski, you testified about water rights in the vicinity of the proposed intakes that will be affected by the Cal WaterFix project. Is that correct?
That's correct.
And as I understand it, you and your colleagues have identified 10 water right holders that will be temporarily affected, and of those 10, 5 will also be permanently affected. Is that correct?
I believe it's 15 total.
Okay.
Check my numbers here.
That was my
Let
question.
me see. Yeah, it's 15 total.
Okay, so just so I'm clear on this, so we've got 10 that will be temporarily affected, and then an additional 5 that will be permanently affected, but we're not counting the 5 under the temporarily affected category.
That's right, but we would go through the same process during the temporary construction activities, then they would convert over to being permanently affected.
Okay. And when you use the term affected in this slide, what do you mean?
That our construction activities would in some measure require us to modify their existing facilities so that they can continue their operation as they do today.
And you referred to construction activities, but I want to focus in on the permanently affected group. I assume that those 5 water users would be affected after construction activities are completed and the project is in operation. So I guess my question is, with respect to those 5, what do you mean by the term affected?
Well, as my testimony stated, we will actually be relocating completely the location of their current diversion to another location. So there'll be another site for their diversion identified and implemented.
I understand that. We're going to get to that in a minute, but I want to make sure I understand your use of the term affected that's triggering these other actions that we're going to talk about. And I just want to make sure I understand how you personally define that term as you've used it in this slide.
Actually, when we reviewed this slide, we felt that there was a typographical error, and we've meant affected, and they were impacted. Could be another term to use in this place, that they were impacted by our operations.
Would another term be injured?
Objection calls for a legal conclusion.
I'm not asking for a legal conclusion. I'm asking for your interpretation of the word that's used in your slide.
No, I would not.
Go ahead.
Do you want me to answer?
Yes.
I would not use that term.
You would not use the term injured.
I would use affected or impacted.
What's the difference between impacted, affected, and injured in your mind?
You're asking for a personal opinion?
Yes.
Injured is that they are in a lesser situation than when we started this project. Impacted, they would have it. There would be a temporary impact, and then we would restore the quantity and quality of water to what it was before the project.
So in your mind, the distinction between injured and impacted is essentially a temporal issue. Is that correct?
In my personal opinion, injured is there is some continuing lasting effect that is of a lesser level than when we started our construction activity.
Okay, fair enough. To your knowledge, is there any document available that identifies by name these 15 water right holders that will be affected?
Yes, I believe that's in the testimony or the documentation here.
I think somebody's phone is vibrating. Thank you.
I believe that's listed in DWR 221.
221, and that includes names of those users?
Yes, it does.
Okay, thank you. Have you or any members of the project design team actually spoken with any of these 15 water users?
Not to my knowledge.
Has anyone affiliated with the Cal WaterFix project spoken to any of these water users, to your knowledge?
Not to my personal knowledge.
Are you aware of any plans to do so?
Not to my knowledge.
Has the project design team done any analysis of the specific water diversion needs of any of these 15 water users in terms of rates of diversion, that sort of thing?
Not at the present time. That activity was going to be undertaken in the future.
Do you have a time frame for that?
If the project is permitted to move to the next phase, preliminary design, we would be beginning those activities at that point in time.
And that would occur after this state board process is concluded?
As far as the engineering team goes, whenever we are authorized to do that, commence preliminary design, we will begin those activities.
So I take it from your previous answers that there really hasn't been any focused analysis of what it will take to fully mitigate the impacts of the project on these 15 water users. Is that a fair statement?
At the present time, yes, that is a correct statement, but as I've stated in our testimony, the department's commitment is to make all of these users whole at the completion of our activities.
If you don't know the specifics about these users' farming operations, how do you know you can make them whole?
We are committed to investigate them and to take the appropriate measures to bring them back to the conditions that they're at now as far as water quantity and quality.
But as you sit here today, you really have no idea how you're going to go about doing that. Is that correct?
We do not have specific methodologies, no, but we have a number of potential activities. Those were listed in my testimony.
Have you done any analysis of the feasibility of farming by these water users after these unidentified mitigation measures are implemented?
Not to my knowledge.
In your testimony this morning, you stated that several of these diversions are not in the State Water Resources Control Board database. Do you recall that?
Yes, I do.
Did you personally perform the search of the State Board database?
I did not personally.
Have you reviewed the search?
I have reviewed that table that was prepared by people that did the search.
But you don't have any personal knowledge of the actual search? You were not personally involved in any way in that search?
No, I was not.
Did you supervise that search?
No, I did not.
So you don't have any personal knowledge about these water users that apparently did not show up in the search of the database?
I do not.
Officer Dodek, I'm going to move to strike from the record the testimony about lack of information in the State Board database regarding certain water users, and this goes both to the oral testimony this morning and also WR2 pages 21, 22, and 23 on the grounds of lack of foundation and hearsay.
Mr. Mizell or Mr. Berliner, your response?
Yeah, as an expert witness, he's entitled to rely on the work of others, which is what he indicated that he's done. I think if Mr. O'Brien's concerned about foundation, then we should direct it to the people that have done that work and explore whether there's foundation for those conclusions. So I'd suggest we hold the question open for the time being.
May I respond briefly?
Mr. O'Brien?
First of all, it's an old trick of litigators to get information in under the guise of evidence relied on by an expert. I'm not accusing Mr. Berliner of pulling tricks, but it happens. There's recent case law, including a recent California Supreme Court case directly on point on this. And the rules are tightening up. You can't put an expert witness on the stand and have evidence that's objectionable based on hearsay or other grounds come in simply because that witness purportedly relied on it. This is a very important issue in this proceeding. This goes to the very heart of the question of whether there will be injury to other legal users of water as a result of this project. It seems to me not unreasonable to require the projects to come forward with witnesses that have personal information about the water rights searches and to basically give us the opportunity to examine those witnesses. So I will leave it at that. If the hearing officer wants to defer ruling on this, I understand, but I just wanted to make that point.
Mr. Bernowski or Mr. Berliner, who on your team did that research in order to provide you with that information which you included in your testimony?
Yes, one of our panelists, Prabha Rubin, was to be on our panel, but he is not available. He conducted that survey and prepared that information.
All right, we will flag that for when Mr. Rubin
Prabha Rubin.
is able to join us.
Right here.
Mr. O'Brien, we will flag that question.
Thank you. Switching gears a bit here, Mr. Bednarski, when you said about the process of developing the conceptual design for the project, did you consider constraints on the way the project could be operated? And when I use the word constraints, I'm talking about regulatory and legal constraints.
No, we did not.
So you just basically designed the project the way you as an engineer would like to see it designed, and you didn't concern yourself with any existing legal or regulatory constraints?
No, that is not correct.
Okay. Why don't you explain what you did?
Which portion of the project do you want me to describe?
Well, I don't want to limit it to a portion of the project. I'm talking about as a matter of process. When you and the design team sat down to start the process of a conceptual design, did you have a discussion or did you take into consideration existing legal and regulatory constraints that might constrain the way this project could be operated?
And I'm going to object to the use of questions on operation. This again is engineering, and they have design constraints and they have design specifications, but operations is for our operation panel.
I believe Mr. O'Brien's question was whether or not those were taken into consideration. And Mr. Bernowski, please answer.
I can only assume that those types of considerations were taken into account prior to specific design criteria being given to the design team to prepare the conceptual design around.
Okay, so
those legal and other regulatory issues that you mentioned.
Okay, that's helpful. So the design team itself didn't consider those sorts of legal and regulatory constraints, but you believe that that may have occurred in some other process, the outcome of which was to essentially give you direction on what type of project to design.
That's correct.
Okay. And this direction you received in terms of the way the project should be designed, what form did that take?
There were other earlier documents that were relied upon that had multiple alternatives identified in those. We built upon those. The capacity of the program was identified to us as far as 9,000 CFFs, the number of intakes. Their capacities were identified to us. The ability to divert certain amounts of water at certain river staging criteria was identified to us. We utilized that information.
In this information that you were provided, was there any discussion about constraints that would be placed on the project operations by the 1981 contract between the North Delta Water Agency and the Department of Water Resources?
I am not aware of that.
Have you ever reviewed that contract?
No, I have not.
So you're not aware of the terms and conditions of that contract?
No.
So as far as you are concerned as a member of the design team, you're not aware of any specific direction that was given to take into consideration the requirements of that 1981 North Delta Water Agency contract when you set about to prepare the conceptual design. Is that correct?
To the best of my knowledge, no.
And there was no discussion in the design process about the 1981 North Delta Water Agency contract or any of the provisions that might be relevant to design?
In the time that I've been on the project, I'm not aware of any.
Okay. You showed a video during your testimony. Actually, I think there were a couple of them, and we can pull it up if we need to, but I'm not sure we will. This was the first video that showed basically the construction. I think it focused on intake number 2. And there was, in and around that proposed new intake, there were some areas of land that had been essentially cleared. Do you recall that?
Yes, I do.
In that video, are you aware of any effort that was made to make sure that those cleared areas of land as shown in the video are accurate in terms of the amount of land that will actually have to be cleared in connection with the construction?
As far as that specific area, when we developed the video, I would not be able to say that that fits exactly with the dimensions that are shown on documents in the environmental impact report of the CER. I believe it was for illustrative purposes only.
Okay, so it shouldn't be taken as necessarily an accurate depiction of exactly how much land will have to be cleared as part of the construction process?
No, it does not.
Okay. Thank you. I have no further questions.
Thank you, Mr. O'Brien. Does group number 10 wish to conduct cross? And if so, Mr. Elijah, would it take more than 5 minutes? All right, please come up then. We will then take a lunch break after Mr. Elijah finishes.
Good morning, Chair Dodek, members of the board. Mr. Benarski, good morning again.
Hello.
Mr. Benarski, I'm here in this iteration on behalf of the City of Brentwood. Do you know where the City of Brentwood is?
No, I do not.
For your information, it's in the Western Delta. Mr. O'Brien just concluded a series of questions or colloquy with you on the North Delta Water Agency contract. Do you recall that discussion?
Yes.
Are you familiar, sir, with DWR Exhibit 305, which is a contract between the State of California Department of Water Resources and the East Contra Costa Irrigation District for the assurance of a dependable water supply of suitable quality?
No, I am not.
During your colloquy with Mr. O'Brien, you indicated that the provisions of the North Delta contract were not included in the design criteria for the California WaterFix project. Is that correct?
To my knowledge, I have never discussed those in my tenure on the project, so if they are incorporated, it's unbeknownst to me.
And would it be fair to say, since you've never seen DWR 305, that the same could be said about the East Contra Costa Irrigation District contract?
That's correct.
If staff could put back up the exhibits that I was using, Department of Water Resources 212, that page, table 4-6. The next page. And Mr. Benarski, under the system mode of operations, would it be fair to say that there is no mention of the East Contra Costa Irrigation District contract or other legal obligations of the department?
That's correct.
No further questions.
Thank you, Mr. Lodgem. With that, we will take our lunch break and we will resume at 1 o'clock.
Yeah, sure.
All right, it is 1 o'clock, and we are back in session. We will now resume cross-examination of panel 2, and next up is group number 11, the water forum. The water forum is not here. Group number 12, County of Colusa, is not here. 13, Sacramento Regional, is not here. 14, Yolo County, is not here. 15, East Bay Municipal Utility District. Good afternoon. Are you Mr. Etheridge or Mr. Salmon?
I am Mr. Etheridge.
All right. Good afternoon, Mr. Etheridge.
Good afternoon. Good afternoon, Mr. Bednarski. My name is Fred Etheridge. I'm an attorney in the Office of General Counsel at the East Bay Municipal Utility District. And for the court reporter's benefit, during my questioning, I may refer to EB MUD or East Bay MUD. That, of course, is short for the East Bay Municipal Utility District. Your testimony provides the engineering project description for the California WaterFix project. Is that correct?
Yes, it does.
And it's based in part on the conceptual engineering report that is designated as DWR Exhibit number 212. Is that correct?
That's correct.
And this morning in testimony or your responses to questioning, I believe, from Mr. Alajim, you testified that that document, the conceptual engineering report, was prepared under your direction. Is that correct?
Yes, it was.
Good. So at this point, the project has been developed to a conceptual level. Is that correct?
That's correct.
Will design continue to be refined in future engineering phases?
Yes.
What are those future engineering phases?
Preliminary and final design.
When will they be completed?
It depends on when the team is authorized to commence preliminary design. Then we'll continue on into final design after that.
Yeah, but it's sometime in the future.
Sometime in the future, that's right.
As to the dual main tunnels that you testified about this morning in your presentation, does your written testimony state that tunnel details, including tunnel alignment, length, depth, and lining requirements, will be refined as geotechnical data becomes available during the next stages of project design?
Yes, they will.
And are those next stages of project design the same thing as the next stages of engineering, the preliminary and final engineering?
Yes, they are.
Okay. How will the petitioners address impacts discovered later in the process during the next stages of design and engineering?
Objection vague. That's an awfully broad subject. If you could be more specific.
Mr. Etheridge, could you be more specific?
Well, we can get more specific later on issues, but the point is that this project to this point has been designed only to a conceptual level. It has not yet been designed to a preliminary or final design level. During the design of the project, as it proceeds through preliminary and final, new impacts may be discovered. How will those new impacts be mitigated?
Answer to your best of your ability, Mr. Bernarski.
To the best of my knowledge, there'll be the mitigation measures would be implemented in a manner that's consistent with what's in the final EIR.
Okay, so the final EIR will drive that mitigation process.
As far as the mitigation measures, yes.
Okay, thank you. Your testimony describes construction activities with the potential to affect legal users of water. Is that correct?
Yes.
Did that analysis of construction activities include EB MUD as one of the legal users of water?
Not to my knowledge.
Okay, thank you. The project's main tunnels are designated in reaches. Is that true?
That's correct.
Which tunnel reach crosses underneath EB MUD's existing McCulmy aqueducts?
I believe that's It's the southernmost reach. Is it 7?
Yeah, would that be reach 7?
Yeah.
If I could ask staff to pull up figure of the DWR Exhibit 212, figure 3-1, that's on page 40. And it should be on the flash drive I provided that has just a few excerpts from Exhibit 212. Thank you. Are the McCollum aqueducts depicted on figure 3-1?
I don't believe they specifically are.
Do you see the dotted line running from east to west above that red type that says reach 7?
Yes, I do.
Do you know what that represents?
Yeah, I believe that's a railroad right-of-way that goes through there, but yeah, I'm aware your aqueduct is near there.
Okay, do you know where the aqueducts are in relation to that Santa Fe Railroad?
I believe they're generally south of it.
Do you know on which island the proposed dual main tunnels cross underneath the existing McCollum aqueducts?
Believe that's that Bacon, South Bacon, or Woodward.
Might it be Woodward Island?
Yeah,
just to
Woodward.
the south of Bacon Island?
Yeah.
Okay.
Yeah.
Are you aware that the McCollum aqueducts convey the primary water supply to over 1.4 million people in EBMUD's East San Francisco Bay service area?
Yes.
I ask staff to please pull from the flash Exhibit 212, page 156. In section 13.2.5, entitled McCollum Aqueducts, this states that the main tunnels will go under the McCollum Aqueducts at the north end of Woodward Island. Is that correct? Do you see that?
Yes, I do.
Can you read that next sentence to me, beginning with these crossings?
Yes, these crossings will be evaluated at the preliminary design level in conjunction with East Bay Mud.
Why didn't DWI analyze the impacts on the McCollum aqueducts caused by the proposed dual main tunnels now instead of deferring such analysis till later?
That would have been a more detailed part of the engineering as opposed to the conceptual level that we're at. We have a number of crossings in various areas through the delta, and those will all be developed in more detail in the next stage of design.
Okay, thank you. In the conclusion of your written testimony, DWR Exhibit 57, you conclude, quote, I believe that the CWF construction will not result in any impairment of water quality or significantly affect other legal users of water. Is that correct?
Yes.
How can you conclude that the project can be constructed without significantly affecting other legal users of water if the impacts of the dual main tunnels caused by their crossing underneath the McCollum aqueducts have not been evaluated yet?
I guess I'm not necessarily in agreement that there will be impacts from the tunnels crossing underneath the McCollum aqueducts.
But do you know if there won't be?
I do not know that there will not be, but I do know that through further engineering investigations, I'm quite confident that we'll be able to design a system that will not impact the aqueduct.
But as we sit here today in this hearing, you don't have the information yet at your disposal to make that conclusion as to the dual main tunnels impacts on the McCollum aqueducts?
I do not have specific information on that, no.
Okay, thank you. Will the dual main tunnels be placed at a sufficiently deep level to avoid directly interfering with the existing McCollum aqueduct pile supports?
I believe they will, but I do not have specific information from East Bay Mud as to the depth of their pile supports.
Do you know that those pile supports are from 60 to 80 feet below MSL?
I believe I do know that.
Okay. Has DWR analyzed the impacts of the proposed dual main tunnels on EBMUD's own proposed Delta tunnel?
We have not been asked to do that in any detail.
Okay. Are you aware that EBMUD's proposed Delta tunnel has been evaluated to a conceptual level of design?
No, I'm not aware of that.
Okay. As you earlier testified, DWR has completed the design of the dual main tunnels to the conceptual level. Is that right?
That's correct.
Is it true that during the future preliminary and final design of the dual main tunnels, tunnel elements may change?
Yes.
Might these changes include changes to the tunnel depth, the location, size, and number of shafts, tunnel diameter, tunnel slope, tunnel lining design, and the spacing between tunnels?
It's conceivable.
If such future changes to the dual main tunnels occur, what changes to the tunnel's impacts on the existing McCollum aqueducts do you foresee?
On the existing aqueducts?
Right.
I don't foresee any impacts on the existing aqueducts. I'm not aware of what these potential future changes would be, so I'm not in a position to really answer what those potential future impacts would be.
Okay, thank you. If such future changes to the dual main tunnels occur, what changes to the tunnel's impacts on EBMUD's proposed Delta tunnels do you foresee?
I cannot respond to that question. I have not seen what you characterized as a conceptual design of your tunnels, so I really cannot respond to that question.
Okay. Moving on to the type of tunnel that will be constructed with the dual main tunnel. If we could pull Exhibit 212 from the flash drive, page 429. Will the lining of the dual main tunnels be constructed of a single layer or single pass of bolted and gasketed precast reinforced concrete segments?
Yes, it will be.
Okay. A secondary liner is not proposed for the dual main tunnels, is that right?
That's correct.
Okay. If I could please ask staff to pull from the flash drive from DWR Exhibit 212, page 432. In section 4.1, there's a sentence highlighted, which I'll read for the record. It says, as the pressure-induced tensile strain develops, radial, longitudinal cracking of the lining will take place, causing permeability of the lining to increase. Because of the cracks, pressure tunnels lined with reinforced concrete are classified as semi-permeable linings. Does this mean that tunnel leakage will occur with such a tunnel?
There is the potential under certain pressure conditions that situation could occur.
So would it be fair to say that single pass concrete tunnels are not watertight tunnels?
I don't, under certain conditions, with a high enough internal pressure, that could be the case.
Okay, thank you. If the dual main tunnels are constructed using a single precast concrete segmental lining, would you expect the permeability of the tunnel lining to increase with time?
Not necessarily. Some of the leakage could could be abated by self-healing or calcification of the cracks, and it could reduce over time.
Are watertight secondary linings used on tunnels in soft ground to avoid risks posed by single layer linings?
I'm not sure that that is the only reason that steel liners would be put inside a concrete segmental line tunnel.
But would a secondary lining such as a steel liner installed avoid some risk posed by single layer linings?
I would not necessarily characterize it as a risk, but a steel liner would certainly eliminate any potential for leakage.
Okay, thank you. Can you please indicate the supporting evidence, such as ground investigations and characterization, that demonstrates DWR's approach of using a single pass segmental lining system only without steel lining or secondary impermeable liner to avoid impacts from the dual main tunnels?
As Mr. Bernarski is thinking about this, let me give some direction to the panel members. Mr. Vallis, Ms. Burkholz, when you have an answer to a question that's being asked, please provide that answer yourself instead of trying to give it to Mr. Bernarski.
I'm sorry, could you repeat the question?
Sure, and this for the full panel. Please indicate the supporting evidence, such as ground investigations and characterization, that demonstrates DWR's approach of using a single pass segmental lining system only without a steel lining or secondary impermeable liner to avoid impacts from the dual main tunnels. We've had over 209 geotechnical investigations along the alignment. And we also passed this proposal for this single pass lining system through expert panels. And that was the recommendation of those panels, to stick with a single pass lining system. And do you know who selected those panels? DWR. Thank you. What is the design life of the dual main tunnels?
The anticipated design life for the tunnels will be designed for a 100-year life.
Okay. What evidence do you have to demonstrate the long-term performance of the gaskets and bolts required for the precast concrete tunnel segments? During preliminary design, we're going to go through some extensive aging testing of the bolted gasket segments, and that will include the neoprene rubber gaskets around the lining system. This is a pre-industry standard design, and it's used throughout the world for lining systems that are geared for a 100-year life expectancy. We're using pre-industry standard designs. Are you aware of these types of gaskets being installed in soft grounds that you likely encounter in the Delta? There are other areas in the world that they are using this. Thames Tideway, DC Water, other facilities. They're building one in Hong Kong right now, world's largest tunnel, 57, almost 58 feet in diameter, using the same process. Can you cite any examples of precast concrete segment gaskets that have lasted for a 100-year design life? No. You know how long the current technology has been in existence for these gaskets? at least 20 years.
With factors such as age-related material degradation, creep, cyclic loading, compression, offset, and fabrication tolerances, can you reasonably expect the gaskets to remain watertight over a 100-year design life?
Those dual main tunnels, fortunately, they're under compressive loads. So the external pressure, from the ground and from water is actually greater than the net pressure inside the tunnels. So these segments will always be under compression. So it'll tend to push the segments together and, in essence, kind of improve the leakage protection because they are being pressed together.
You jump to DWR Exhibit 212, page 427, and that should be on the flash drive as well. So. There we go. There's the paragraph that begins, one of the critical design. I'll read the first sentence of that. It states, one of the critical design issues for the project is determining a feasible and cost-effective lining system for the tunnel that can withstand the external loads acting on the tunnel, but also the internal water pressure. So does this mean the tunnel lining must withstand both the ground overburden on top of the tunnel and the internal pressure within the tunnel?
That's correct. And it's designed for not only in-place loads, but also transportation loads, erection loads, meaning loads from the tunnel boring machine as it pressurizes the edges of the segments, and any internal pressure from the water, internal water pressure.
Can the net internal pressure be reliably balanced by the soil overburden load in the long term?
We believe so.
And upon what evidence do you base that conclusion?
The soil tends to creep, means it wants to move and grab the tunnel. So it would creep around the tunnel segments and actually compress them. That's just a tendency of soft ground.
Would you please pull up DWR Exhibit 212, page 143? There's, in the middle of that page, there's a series of 5 bullets, and I've highlighted a sentence in the second bullet, which I'll read for the record. It says, ground overburden to counteract the internal pressure is ignored at this conceptual phase, but will be considered during preliminary and final design once detailed geotechnical data is available. So is this another example of this conceptual level? You haven't looked at this yet, but have ignored it now, but we'll pick it up later during later stages of project design?
It's not necessarily ignored. It is taken somewhat into consideration. At this point in time, we ignored the overall ground loads because we knew we had sufficient external water pressure to balance the internal water pressure. And it's a very, very conservative design at this point. Once you actually apply the external ground loads, it's even a better situation than it's currently designed to.
Okay, thank you. What analysis or numerical modeling will be performed to confirm that a single pass system is feasible, considering that the proposed dual main tunnels will be pressure line tunnels in soft ground?
They'll use many different types of finite element analysis, 2D, 3D, including the connections to the shafts where there's earthquake loading that gets applied, and they'll make sure that the tunnels are appropriately designed, both from a thickness standpoint, reinforcing standpoint, and overall weight of the individual segments and how they're being transported.
Okay, thank you. Could pull DWR Exhibit 212, page 432. That should be on the flash drive. At the bottom of this page, there's a table 3. Do you see that? Could be any witness on the panel. You see the table 3 entitled Summary of Leakage Estimates for Lining Alternative A1?
Yes.
And that table states that estimated leakage rates for reaches 1 through 5 of the dual main tunnels range from 6.3 to 11.3 CFS per 1,000 linear foot of tunnel. Is that correct?
Yes, this looks like it was taken from an old CER. The 2012, that's when we had a completely pressurized system with a pumping plant at the north, and it was literally pushing the water through the tunnels. The actual heads that are being shown there in the table above are actually much higher heads than what we're currently identified in the California WaterFix.
But this table is from DWR Exhibit 212, is that correct, at page 432?
It looks like that's correct.
And that is the July 2015 Conceptual Engineering Report, is that correct?
I believe so.
So is what you're saying is that the project as it's currently configured is different than what's displayed in this Conceptual Engineering Report?
Yeah, this is identifying alternative 1A.
Does this table include reaches 6 and 7?
I do not see that.
Can we scroll down to see the next page? I'm not sure that it was carried over or not.
You can get it if you pull up the full Exhibit 212. I'm sure that it's not. But
No.
we can do that if staff can pull up the complete exhibit DWR 212, page 432 and 433.
Good match.
You see there at the bottom of page 432 has table 3, and in the column 1 it speaks to reaches 1 through 5, and then on the continuation on the next page 433 there is no table. Is that correct?
That's correct. Do we have the section numbers so we can refer to it in this hard copy that we have of that document? Section number that memo would have been placed into.
Is it possible to go to the cover page of that section?
Yeah.
It's Appendix J.
It looks like it's Appendix J. That should be on page 212. That's the title page for this section. Sorry, page 425. Scroll up. Yeah, there you go. That's the section that these pages are in.
Yeah, so this document and memorandum was written in 2012 by one of our consulting engineers that we asked to analyze specifically the tunnel lining system.
Okay, and I think you testified a couple of minutes ago that the project design has since changed from that evaluated here.
Yes, it has. It's been described otherwise in the main body of the CER.
Good. Do you know the estimated leakage of the dual main tunnels underneath the McCollum aqueducts of the project as it's currently
I do not
construed?
recall that.
Okay. Might effects of leakage from the dual main tunnels include loss of soil strength or loss of soil mass?
Yes, it could.
Thank you. What analyses have been performed to assess potential impacts on the EB-Mud-McCollum aqueducts from changed ground conditions resulting from construction and operation of the dual main tunnels?
We have not conducted those analyses at this point in time.
Okay, so that would be another category that would be conducted later at the preliminary and final design stages?
That's correct.
Okay, thank you. What geotechnical subsurface investigations and testing and analysis are planned for the future design of the dual main tunnels?
Go ahead.
Our current geotechnical plan calls for 1,500 borings and CPTs. Essentially, we're planning a boring every 500 feet along the length of the alignment.
And then what will you do with the results of those borings?
We send them to a lab to actually analyze the information, and then give us, then from there we send it to geotechnical experts that will interpret the data and give us recommendations in terms of capacities for shear, soil bearing capacities, loads that could be applied to the ground, and also any abrasive tests that need to be performed so that we can actually size the tunnel boring machine appropriately.
Might the results of those investigations change the tunnel elevation of the dual main tunnels?
Not necessarily the investigations. We can design for the depth that we have. Other factors may. We want to make sure that we stay in as safe a zone as possible. So we would consider other factors.
Okay, thank you. During construction of the dual main tunnels, could factors such as ground loss at the tunnel face and insufficient grouting of the voids between the excavation and the lining result in foundation settlement of the existing McCollum aqueducts?
Yes, they could.
Okay. Could such factors also result in foundation settlement of EB-MUD's proposed delta tunnel and the surrounding levee system in the area?
Yes, if not monitored and prevented.
Will DWR conduct an advanced ground improvement program, such as jet grouting or alternative methods to stabilize the ground, as part of the project to reduce the risk of settlement on critical infrastructure, such as the McCollum aqueducts?
Yes, the need for those methods that you described would be identified in preliminary and final design.
They're not defined at this time, is that correct?
That's correct.
Will DWR implement a monitoring program to assess groundwater levels, settlement, and structural deformations of the McCollum aqueducts to determine impacts of the construction and operation of the dual main tunnels?
Yes, we will.
When would such a monitoring program begin?
While no start date for that has been identified yet, I would anticipate that it would be well in advance of construction, and in order to assist us in collecting information for the preliminary and final design, that monitoring program may be started in that phase of the project.
So in other words, if the monitoring program began prior to construction, would that give you a type of baseline to assess project impacts against?
Yes, it would.
Okay, thank you. And how long would the monitoring program continue? Would it just be during construction, or would it go for the operation of the project as well?
That has not been determined yet.
Would the monitoring program also include the surrounding levee system?
Oh, yes, it would, but if you could be more specific about which levee you're referring to.
Well, the levees around Woodward Island, for example. East Bay Mud would be interested in those levees that protect the islands over which our aqueducts pass.
Yes, it would then.
Okay, thank you. I want to ask a few questions on the vertical alignment. I believe your testimony states that the invert of the project's dual main tunnels ranges from -147 to -163 feet below MSL. Is that correct?
That's correct.
Do you recall what the tunnel invert was described in the 2013 BDCP EIR as the project was construed at that time?
No, I do not.
I asked staff, I don't know if we've had any luck pulling this up, but to pull up the BDCP EIR, EIS, I believe it's State Board Exhibit 4, and there's a figure 3-20. Oh, excellent. Thank you. What's displayed on the screen here is figure 3-20 entitled Tunnel Configuration, and this is from the 2013 BDCP EIR EIS. Do you see that?
Yes, I do.
It may be very difficult to read, but in the lower left corner of this figure 3-20, there's a tiny
I'm sorry,
print.
3-21. Which one are you referring to?
Well, we can do 3-21 will work.
Okay.
In the lower left corner of that, there's some very small print, but at the last line of that reads, adapted from DWR 2010, Conceptual Engineering Report, all tunnel option, figure 11-6. So from this, I gather that DWR has done a series of conceptual engineering reports. Is that true?
Yes, it has been done that way.
And is the most recent conceptual engineering report what you have identified as DWR Exhibit 212?
Yes, it is.
And that's the 2015 CER, is that correct?
That's correct.
Okay. But back in 2010, was it expected that the typical depth of the dual main tunnels would be 100 feet MSL?
Objection, relevance.
I think it's very relevant.
Sure.
The project has evolved over time, and it keeps evolving, and it's not set yet because we'll have future preliminary and final design. What I'm simply trying to draw here is that in the 2013 EIR EIS, the tunnel depth was expected to be 100 feet, and now it's 147 to 163, so it's changed substantially in that short period of time.
Please answer.
If I may, I'd like to answer that. In the 2013 draft EIR, draft EIS, one of the things too was in that process was that we were trying to see if we could hold ahead with pumping plants at the intakes before we moved the pumping plants to Clifton Court. So with that as a pressure line, it could be at a higher elevation than trying to do gravity flow.
Okay, thank you. So might the tunnel invert change again from what's described in your testimony today as being ranging from -147 to -163 feet below MSL?
Depending on our findings from the geotechnical investigations, that could have some effect on the final tunnel vertical alignment, and then also through our discussions with agencies like yours and others that we will be engaging in preliminary design, there could be some slight adjustments to the tunnel depth.
Okay. Would you expect those adjustments to tunnel depth to be, as you just said, slight, rather on the order of magnitude from 100 to -147 to 163?
Somewhere in that range.
But I probably didn't ask that question very well, but would you expect future changes in the tunnel invert to be, as you said, slight rather than significant?
Well, I guess slight is a vague term.
It is.
Yes.
Well, would you expect them to be changed to the same degree that they did from 2013 when it was expected that the typical depth would be 100 feet to where they are today from 147 to 163?
No, I do not expect that any changes would be of that magnitude.
Okay, good. Thank you. If I could ask staff to pull from the flash drive excerpts from Exhibit 212, page 133. Highlighted sentence there, Mr. Bednarski, could you please read that?
Yes. All tunnels slope continuously from north to south without siphons.
Okay, thank you. Do you know what the proposed slope of the dual main tunnels is?
Essentially, because we're talking about 30 miles, that 13-foot difference there is basically flat.
Right. And as you testified this morning, the water under certain conditions will move through the dual main tunnels under gravity flow. Is that correct?
That's correct.
So would you expect that slope to be able to convey the water from the northern end to the southern end of the dual main tunnels?
Yes, I would. Under those conditions that we've identified where gravity flow could be effective in moving the water that way.
Okay, thank you. I could ask staff to pull another excerpt from DWR 212. This is page 138 on the flash drive. And this states that the main tunnels and the north tunnels, tunnel reaches 2 and 3, are assumed to be spaced at 150 feet, center line to center line. Is that correct?
Yes, it is.
Why do the tunnels need to be separated?
It's primarily an issue with construction of the tunnels. They need to be separated so that the tunnel boring machines can mine the tunnels running parallel to each other without impacting the tunnel construction of an adjacent tunnel boring machine.
And construction aside, do tunnels influence one another in the ground?
Once they're constructed, I'm not sure of your question.
Well, do tunnels influence the surrounding soil for a substantial distance around the tunnel bore after they're constructed?
I guess you'd have to define substantial, for there is some zone where there would be an effect, yes.
Okay, and is there a name for that zone?
I don't recall what that term is.
Okay, thank you. You testified earlier this morning that the project includes construction and access shafts for the dual main tunnels. Is that correct?
Yes.
If the locations of the dual main tunnels access shafts change during the preliminary and final design in the future, will DWR restrict construction of the access shafts so that they are not close to the E.B. Mudd McCollum Aqueducts right-of-way?
Close is kind of a vague term, but we would coordinate with your agency to make sure there were no impacts to your operations present or future.
Do you know the minimum distance to the McCollum Aqueducts right-of-way that the access shafts could be placed by DWR?
I do not know.
Okay, thank you. Will DWR restrict the siting of the dual main tunnel safe havens and intermediate shafts to avoid being in proximity to the E.B. Mudd Aqueducts right-of-way?
Yes, we would, with the clarification that the normal safe havens would be situated to avoid your facilities. However, if there was a situation where, let's say, call it unscheduled maintenance of the tunnel boring machine was required under or near your aqueduct, then we would need to create a safe haven underneath your aqueduct, but that would not be a planned situation.
Okay, thank you. In your written testimony, you discussed the earth pressure balance and tunnel boring machines. Is that correct?
Yes, I did.
Are you aware that In other soft ground tunneling by closed-face earth pressure balance tunnel boring machines, sinkholes have developed?
Yes, I am.
For example, are you aware of tunnel boring machine projects where sinkholes have occurred, such as the Beacon Hill Transit Tunnel?
Yes, I am.
And similarly, the LA Metro Red Line Tunnel?
Yes.
How do you distinguish the proposed dual main tunnels from those other projects where sinkholes developed?
I believe that the understanding of the design, construction, and operation of earth pressure balance machines has evolved greatly since those two examples that you gave me. I believe that designers of tunnels and contractors and operators of tunnel boring machines have a greater appreciation for the risks related to tunneling in soft ground with pressure face tunnel boring machines, and that there are adequate measures now on board these tunnel boring machines to mitigate those types of events.
Does the potential still exist for major ground loss associated with tunneling for the dual main tunnels, thereby resulting in sinkholes?
I'm sorry, could you?
Does the potential exist with this dual main tunnels project for major ground loss associated with the tunnel resulting in sinkholes?
I believe there's always the potential, if the equipment is not operated properly, if the system is not designed properly, for those kinds of conditions to occur. That is not our intent with when we proceed with preliminary and final design, and also with construction management of the future construction contracts related to those tunnel reaches.
Okay, thank you. Let me just take a minute to check my notes. Okay, that concludes my questions. Thank you.
Thank you, Mr. Etheridge. Group number 16. Thank you, Mr. Adams. Group number 17 is not here. Group number 18 is not here. Group number 19. Ms. Mercerf is coming down, I believe. Ms. Mercerf, one question before you begin. Are you also representing Group 20? Or will Group 20 have cross-exam separately?
Good afternoon. Good afternoon. I did have a point of clarification, which I think will answer your question. I did want to point out that I've been grouped with quite a few parties, which I'm really the secondary authorized representative. And so I just wanted to point out that those other authorized representatives may show up at any time, and I believe they're aware of the schedule, and but I don't want to make any representations with respect to their appearing here when it's actually been me as a secondary person who was authorized in order to make sure that they could be covered when they couldn't be here, and asked me to do specific things.
All right, thank you.
But with respect to your question regarding Mr. Daniel Wilson, I do not believe he will be here today.
Thank you.
And just to clarify for the record, the questions that I'll be asking today are primarily on behalf of local agencies of the North Delta, Bogle Vineyards, Diablo Vineyards, Stillwater Orchards, and Islands, Inc., as well as I have one thing for Daniel Wilson, and the representative from Antioch has asked me to ask one question, which I said I would do, which relates to some of my concerns as well.
I'm sorry. So you're also covering group number 27.
Just for your information, I don't believe he will be here today.
Thank you.
Just if that helps in your planning. So So, Mr. Bernardsky to begin with, but if there's others on the panel who have answers, I know Ms. Buchholz has quite a bit of information regarding this project, so I'm open to that. But so you're providing, Mr. Bernardsky, expertise regarding the project description, status of the engineering completed to date, potential flooding, seepage impacts from construction, and impacts, at least to some extent, from construction of the project, although I understand you've referred certain questions to other panels that will be coming later, correct?
Yes, I have made that reference.
Okay. And also just to clarify, you're an employee of Metropolitan Water District of Southern California, correct?
That's correct.
Where do you work physically?
A portion of my time I work in Los Angeles, and a portion of my time I work here in Sacramento.
Do you have an office here in Sacramento then?
Yes, I do.
Is that within the Department of Water Resources?
Yes, it is.
Is that within the entity called the Design and Construction Enterprise, just for clarification?
Yes, it is.
And do you know how, I assume your salary is paid by Met, correct?
That's correct.
So do you know how the cost of your work with respect to this project, which has many parties wanting to construct it, how that's accounted for?
Objection, relevance.
Ms. Nassif?
I'm just trying to establish who, what his position is, where his background is, and who he works for.
I don't see how salary plays into that.
Ms.
It's
Nassif,
my
again?
understanding that there's some kind of reimbursement scenario with respect to the State Water Project because this is not supposed to be something that falls on taxpayers. I'm just asking about how it works. If I don't need to go further if there's a huge problem with it. Okay.
Okay, thank you, Ms. Nassif.
Okay. Let's see. Okay, so with respect to the Design and Construction Enterprise, that's the entity that was formed to actually undertake construction should this project proceed, correct?
Yes, design and construction and management of the program.
So it's my understanding, and correct me if I'm wrong, that DWR doesn't intend as an entity to carry out the construction of the project, correct?
I believe that the design and construction enterprise is part of DWR. So as much as the design and construction enterprise will be implementing the project, I believe it would then fall under the auspices of DWR.
In some of the testimony in the past today, and then I may come back on it further, there's been a lot of references to mitigation measures and things that would happen in order to prevent effects on other people and water users within the Delta. Who would be responsible for those?
The draft EIR-EIS and the draft and the recirculated draft EIR, supplemental draft EIS, indicate that DWR, who would be responsible, lead agency for the construction, would be responsible for the final adopted mitigation measures with respect to construction.
So if a person's water supply was cut off due to construction, who would they call?
At that time, there would be a program already set up, as we've pointed out in the mitigation measures in the environmental documents, that there would be a monitoring program that would have outreach to the landowners, and the specific person that would be identified by DWR, who the owner of the construction project, would be identified in that process at that time.
So it may be, would it be fair to say it may be an employee of DWR, or it may be someone else who works for one of the water contractors or somebody else altogether?
I don't want to speculate how DWR is going to put that in the future documentation.
Ms. Buchholz, you've referred to mitigation measures. I know you're aware that in Appendix 3B of the 2015 RDEIRS, that there's also a thing called environmental commitments.
Yes.
Many of the things we've been discussing today are in fact within the list of environmental commitments, not mitigation measures, correct?
That's true.
Can you explain to me what the difference is, please?
The environmental commitments are part of the project description, and versus the mitigation measures, which are identified. So we take the project description and run it through the impact analysis under the different resources in the environmental documentation. If we've identified potentially significant adverse impacts under CEQA, we've then identified mitigation measures to reduce those impacts, hopefully to a level of less than significance.
And what about the environmental commitments then?
The environmental commitments are part of the project description, so they are the definition of the project and have already would be whatever the environmental commitments are for the proposed project that's adopted in the notice of determination by DWR and the record of decision by what in the sense of construction would be the notice of determination by Department of Water Resources. Then those would be part of the project description and committed to.
How would they be enforced if not through the mitigation monitoring and reporting plan?
The mitigation monitoring and reporting plans generally also include the project description as defined in the part of the final environmental impact report, and then as well as the mitigation measures, and they're all a part of the commitments. Generally in the mitigation monitoring and reporting plans, they'll also include a map, or sort of a roadmap of which ones would be connected with which permits. And so there would be many ways to look at that plan that's always prepared as part of the subsequent to the final environmental impact report.
And then today there's been a lot of reference back mostly to the mitigation measures, and I just want to be clear that a lot of these things are a different thing called environmental commitments. But are there additional mitigation measures or environmental commitments that have been discussed today that are not contained within the 2015 RDEIRS?
There could be, because we are currently preparing the final environmental impact report, final environmental impact statement, following review of the comments on the recirculated draft EIR, supplemental draft EIS.
And when do you expect the final EIRS will be available?
I don't have a date at this point in time.
Do you expect that'll be prior to the close of this part of the DWR's presenting of its petition?
I actually do not know that answer.
The reason I'm asking is I guess I'm wondering what the petition is for, and if there's important parts of it, perhaps such as I would bring up as an example, the cutoff walls that are described in your groundwater memo, Ms. Buchholz. How is it that we know what the project is right now? Because I don't know what else there is besides that groundwater memo.
Okay, and that's in response to DWR Exhibit 218, which I prepared. We felt in response to comments, well, there were two things on that. One was certainly in response to comments, but also there was a disconnect between the recirculated draft EIR EIS project description, which included the slurry walls, and Chapter 7's groundwater impact analysis, which I didn't take that into account in the impact analysis. So we realized that as we were preparing the final EIR EIS, and therefore we had prepared that memo from the groundwater team that I manage to submit that back to Department of Water Resources, that this will be a change in the final EIR EIS.
And there probably are other changes to both the project and also to the mitigation measures and environmental commitments, all three of those things that we should expect to see, correct?
On the portions of for the respect to chapters 5, 6, and 7 on the water supplies and surface water, I am not aware of anything else of that, of any other changes like that.
With those chapters are the ones you've worked on?
Those are the chapters that I manage, yes.
I'm going to come back to groundwater in a bit, but I want to go back to just some basic what this project is. And I have a, let's see, DWR 212 figure 19-2 I've put on my thumb drive as a separate file. And I wanted to touch on, I'll wait till. Sorry, I don't have them in a particular order. I'm sorry, it's DWR 212, figure 19-2. I have a separate file. Yes, thank you. I don't think I've done as well as Ms. Seward, I'm sorry. So,
It's something to aspire to.
yeah, I know. Okay, so I want to talk about the power demands, or ask about the power demands for the project, if you would. This isn't something I don't think that's covered in either the PowerPoint DWR2 or the testimony DWR 57 to any extent, correct? Mr. Bednarski?
I don't believe so. I don't think we outlined the power demands.
Don't the power demands impact, I mean, isn't that part of the project, the fact that it requires power both for construction and operation?
Yes, it does.
Why wasn't it included in your testimony?
Oh, yeah.
Objection relevance as to what this has to do to injury to legal users of water?
This is the engineering panel. The project's being described. There's a huge component of the project which has not been described. I believe there is a connection to legal users of water. However, I think we're just at the point of trying to understand what this project is, which I believe this panel is here to tell us.
Agreed. Please answer.
Those aspects that you referred to were not included because the instructions that we were given in preparing our testimony was to take a narrow view of the project in relation to legal users of water, and the nexus between the power supply to the project and the legal users of water was not identified as being needed to be included in my testimony.
This figure from the DWR 212, the 2015 conceptual engineering report, to your knowledge, does this reflect the current power plan for the project, or is this outdated? You want me to ask separately?
Can you scroll more?
So maybe it could go smaller just so he can see the... I took this directly from there. I didn't do anything to it.
I believe it does, yes.
However, is it true that the location of these exact facilities is in negotiation with the potential power providers still, however?
I'm sorry, which locations are you referring to?
The area I'm looking at mostly is in the northern area where you would see the green line and then the lines headed up to the 3 proposed intakes. You could just limit it to that.
So you're asking...
I'm asking whether this is the set route of it, or if this is a conceptual plan also.
I believe that a conceptual route was identified for the purposes of the EIR, and that reflects, what you're showing there reflects that conceptual route. A final route has not yet been determined.
In your testimony, you discussed how the project is gravity-based. In fact, doesn't the project require significant power to operate?
If my testimony indicated that the water would always flow by gravity, that was not the case to North Clifton Court. The water will flow by gravity at all times to the pump stations in the south. And at that point, under some river conditions, the water can continue to flow by gravity into North Clifton Court. Under other river conditions, the water will need to be lifted at the pump stations and placed into North Clifton Court.
But just to clarify, I mean, we're looking at 230 kilovolt transmission lines, and whether you're looking at the northern ones or the southern ones, I believe let me just clarify. The change to the project that you had discussed as a refinement earlier was to center the pumping plants in the south rather than the north. And that's where the major power supply would be needed at this time.
That's correct. We do have tunnel boring equipment that we need to operate, which take quite large loads. And my recollection is that the green line at that high voltage was necessary to come over from a substation and then would be stepped down to, I believe it's the 69 kV power that we would use to run our tunnel boring machines and any of the other site equipment necessary for construction.
On that green line, the RDEIR suggests that this transmission line is temporary.
The green line?
Yes.
That's correct.
Is there a funding source provided to remove the line afterward, like an endowment?
The funds to remove temporary lines, not just that one, but any other temporary works that would be constructed as part of our budget for the overall program.
Where could the budget for the overall program be found? I didn't see that in the RDIR.
That is not, the cost estimate is not included in the environmental documentation. It's in the CER.
If you want to see a detailed budget breakdown, it's one of the public documents. I think it's budget and schedule for the DCE.
Is that part of the evidence here before the water board yet, or is that something on your website?
I think that's something on the website.
Okay. Okay, but so Ms. Buchholz and others on the panel, correct me if I'm wrong, you're saying you are budgeting for removal of the power line shown in green?
Yes, that is correct.
Okay. Now back to the tie-in to legal users of water. This is a pretty large construction project to wherever it is, whether it's on the green line or somewhere else. Isn't it possible that there could be impacts on legal users of water within that, I believe it's an 8-mile length?
Objection calls for speculation.
Let me ask it this way. Has anyone on the engineering team investigated or elsewhere, other teams, about whether there's impacts to legal users of water from construction of the transmission lines?
Not to my knowledge.
If I may add to that, the mitigation measures in chapters 14 and 20 are for mitigation measures to users of water are inclusive of all facilities associated with the conveyance, and that would include the transmission lines as be part of the conveyance facilities.
Okay, could you put up, please, the one I have labeled intakes overview figure? This is a map that we've prepared. I'm just providing it for for explanatory purposes right now of what I'm talking about. I may submit it later as evidence as part of my case in chief. And just to explain, the green line that you saw on the previous slide from the CER is shown now in black going across. Are you aware, Mr. Bernardsky, of the Stone Lakes Wildlife Refuge boundary that's shown in green here?
Yes, generally I'm aware of that.
In your design scenarios or in your design work for the project, have you considered undergrounding these power lines?
We have discussed undergrounding as a potential mitigation measure, yes.
That isn't part of what's being proposed thus far, though, correct?
I do not believe so.
Well, since we have the refuge map up, I'm going to move into a groundwater question that pertains to the refuge. Are you aware, Mr. Bernardsky, I think, or maybe this is better for Ms. Buchholz, I'll let you guys decide. Are you aware of the refuge's groundwater wells within the green area? I don't have them marked there, I'm sorry.
We don't have the locations of any of the individual wells specifically at this point in time. Identification of those locations and monitoring of those or testing of those would be done during the pre-design portion of the project.
Are you, Ms. Buchholz, you recall from the RDEIR, at least, figure 7-27, that it showed groundwater levels sinking maybe about 4 feet during construction, correct?
That is true, and that's what was in both the draft EIR-EIS and the recirculated draft, supplemental draft EIS. And that was the purpose of the memo that's showing up as DWR Exhibit 218. The change in project description between the draft EIR-EIS and the recirculated draft EIR-EIS associated with the intakes and tunnel shafts, in which slurry walls would be constructed around their entire construction area instead of just adjacent to the river as it was in the draft EIR-EIS, was not accounted for in our impact analysis. That was a change between draft and recirculated draft environmental documents. That change in the project description in Chapter 3 of those documents was not accounted for in our impact analysis in Chapter 7 of the recirculated draft EIR-EIS. Therefore, prepared the memo to DWR indicating what the changes would be in the impact analysis that should have been included in recirculated draft and will be in the final EIR-EIS, with the impact of the slurry walls around the entire intake and the dewatering mechanisms within the slurry walls. We do not anticipate any groundwater reductions outside of the slurry walls, especially into stone lakes.
Right, just to point out, the reason I'm asking, the intermediate forebay is the small rectangle shown toward the bottom of the screen within the boundary of the Stone Lakes National Wildlife Refuge, although it is not on land owned by the refuge itself. It's part of the overall planning area.
And if I may, to the chair, that the intermediate forebay project description will be modified in the final EIR-EIS, and that was also included in my memo. There was a suggestion in the mitigation measures in both the draft and the recirculated for the forebays to also have slurry walls around their entire construction site, and those will be included in the final EIR-EIS to have a slurry wall around the entire intermediate forebay, therefore protecting the groundwater on the adjacent properties.
As was discussed previously, however, it involved whether you could key into the clay layer. So, and then you've also said that you didn't have very much geotechnical data. So isn't it still somewhat of a question whether these things will be effective?
There were some geotechnical data in there that, and I could pull those up if we wanted to take the time. They're in my binders adjacent to me. Where I had exactly one, but I actually personally looked at the boring logs at the intakes and at the two forebays areas, the areas of the forebays, to confirm that we had adequate clay lenses that we could probably get down into those areas. If not, we could use grouting. That's a really typical way of doing it. I've been on construction sites in the past in which we've actually done that when we could not get down to clay lenses. One in particular was along Monterey Bay where it's nothing but sand.
Okay, so just coming back to the questions, let's see. So under a mitigation measure, well, the refuge uses the water supply from the groundwater for both for maintaining some of the water features within the refuge for wildlife. Mitigation measure groundwater 1 currently doesn't include replacement water supplies for that wildlife, however, correct?
Not sure I agree with that, but I'd have to check to see how you're reading that, because I think it would affect any of the wells.
Okay.
I can't remember that in groundwater, we didn't differentiate between the use of the water when we talked about the wells potentially being affected.
Okay, yeah, that's all I'm trying to clarify, because that certainly would be a beneficial
No,
use.
we didn't do that in Chapter 7.
Okay. In developing your approach to protection of groundwater, did you consider compliance with the Sustainable Groundwater Management Act?
At the time that we did, certainly in the draft EIR-EIS, that act had not been even prepared. By the time we went to the May 2015, we looked at the Sustainable Groundwater Management Act as a cumulative project because we weren't sure how the implementation of that act was going to occur. We are recognized that by early 2020s, the act will be, the plans need to be completed, and they need to be implemented over the next 20 years. The end of the study period here that we're looking at immediately during construction is around 2030. We will have to work with the landowners and the agency that is implementing the groundwater management plans along the entire conveyance to see how those are being established along that area, because it would be another process that we need to integrate with during the design and during construction. But it was handled as a cumulative project in the environmental impact report because we don't have enough details because the plans haven't been developed yet.
And also the lack of closure on what your own plan is for this area would also be another factor in not being able to know how you would impact future groundwater plans, right?
If I may, I'm not sure I'd say lack of closure. I'd say that the fact that we recognize that we need additional geotechnical and well information, both in location, well logs, and production rates of nearby wells, and that was always planned to be obtained during as usual in these projects during pre-design and design.
So there would be the potential, would you agree, to impact compliance with basin plans developed pursuant to SGMA?
I don't know if I would say that, because I think that it would depend on what the groundwater management plan is and how we'd work with it like we would any other plan that was already adopted in place at the time.
Okay, I'm going to switch out of groundwater, and I want to just follow up on some questioning that you heard from Council for North Delta Water Agency, just to clarify where the project is at in terms of its understanding of impacts on other legal users of water. I'd like to look at the file called Exhibit B, Bogle Diversions. That one, yeah. As part of my protests, which is so already part of before the board now, I've prepared maps that show where the diversions of the different groups are located. And this first one is diversions that serve the Bogle Vineyards, which you may be familiar from drinking their wine. And I want to know from, I guess, primarily Mr. Bernarski, maybe you could zoom out just so it's more of an overview, if you don't mind. Thanks. Were these diversions considered in your design criteria, or I'm sorry, your engineering criteria in terms of reducing impacts on users of water?
If you're asking if we looked at them from the same standpoint as the information I presented today, with diversions that fall within the footprint, either temporary impacts or permanent impacts at the three intake structures, without knowing specifically about where one or two of those lay near the intakes, we did not do that detailed review on any of the remaining ones that are there. So if there's a way to zoom in and tell whether those one or two others near intake 3 fall within the footprint and match up with the information that I presented earlier this morning, then we would know whether those diverters were covered in our review.
So this particular map actually doesn't show any, these diversions are actually across the river. So they,
Okay.
the issue would be water levels and water quality and reverse flows, those kinds of things. So is it fair to say that these diversions weren't considered in any way in your design? Specifically these ones?
This in a part of the analysis was being done as part of the, it'll be discussed as part of the modeling panel. It'll appear 2 panels from now.
So there wouldn't be any information within the purview of the engineering panel with respect to how much water is needed, what kind of crops, or anything like that, correct?
No.
And what about, would there be any information about the timing of water use and when these intakes require water to irrigate their crops?
That wasn't considered by the engineering panel team.
I'll just quickly go through a couple of other exhibits to get past this point. So if you could bring up Exhibit B, Elliott diversions. Zoom out, please. This map shows one diversion called Rose, which is under the footprint and is listed as a temporary impact. But with respect to the other diversions, I would just ask the same question, and I'll just ask it as one thing. Were any of these other diversions besides Rose considered in the engineering of the project?
No.
And then I have one more map called Diablo, or Lang Twins, it says. And would be the same answer here, whether any of these were considered in the engineering of the project to reduce impacts.
No.
Then I have one other exhibit would be one called Islands, Inc. Scroll to the last page of this, please. Yeah, I didn't do as well as Nikki. Okay. This shows diversions on Ryer Island that belong to Islands, Inc., which is a separate protest. These also wouldn't have been considered in your specific engineering exercises that we've been discussing today, correct?
Objection, Veg. There's a lot of writing on this. Are you asking for every piece of writing to be confirmed, or just the highlighted portions, just the green, just the yellow? Could you specify?
Sure, yeah, I'm just referring to the siphons, which are labeled with an S. Sorry, there's some extra highlighting, but it's really just the intakes around the island that I'm referring to.
The engineering panel did not analyze these. These are considerations that will be discussed in the modeling panel.
I will follow up with them later. Thank you for clarifying. I have another engineering question back on the FOREBAY, which I think the GWR 2 slide, let's see, it's slide 8. It's the one that shows the actually, can you go to the slide 10, please? I'm wondering if you can clarify with it's not really shown very well here, I think, but with respect to the route from the intake itself during construction to the intermediate FOREBAY, is that above ground or below ground, the individual? It appeared there was some writing that showed that some of that would be above ground disturbance, and I'm just trying to clarify that.
All of the 3 intakes are connected to the intermediate FOREBAY by tunnels.
During construction, would there be any above ground disturbance?
Yes, there would be. I believe those have all been indicated either in DWR 212 or in the accompanying documents for the recirculated EIR-EIS.
To your knowledge, would any of that disturbance be above ground and across either irrigation or drainage ditches that are serving the farms in between the intakes and the intermediate forebay?
I cannot respond as to specific ones, but in general, yes, there would be.
There would be disturbance. So,
Yes.
but there's only one exhibit, is the diversions that are under the footprint. How did your team account for the other water uses that would be potentially disturbed by the above ground activity we're discussing right now?
In Chapter 14, the mitigation measures that we're concerned about effects on agriculture as a result to disruptions of agricultural infrastructure on page 14-49 in the 2013 draft EIR-EIS and the associated mitigation measures that would be there, and it was also repeated in the recirculated draft on page pages 14-19 of the recirculated draft EIR-EIS and the mitigation measures. There were to do a series of combining the implementation of measures AG-1, GW1, GW5, and WQ11 to reduce the severity of these impacts on the agricultural users. And that could mean relocating them. It could be working around this disruption if it's temporary. There could be many things that are outlined in this mitigation measures.
Just to clarify, however, I mean, an irrigation ditch or water works, that's part of the legal use of water, correct?
Yes.
And are you saying that the mitigation measures you've pointed to will completely eliminate any and all impact whatsoever? I'm a little confused what you're saying.
The focus of these mitigation measures are to reduce these impacts, and there's a stepwise series that are associated with mitigation measure AG-1 that proceeds in a stepwise manner to minimize these the impacts of these potential changes to or potential effects on agricultural infrastructure.
However, the standard for significance to agricultural impacts under CEQA would be different than the standard, which is injury to legal users of water, wouldn't it?
Objection calls for a legal conclusion.
I'm not sure.
Ms. Buchholz's testimony appears to be that the mitigation measure provided for CEQA is going to be sufficient to prevent all legal injury. Is that what she's saying? It's a menu of options, I guess, is the problem I'm having.
It's a commitment to avoid disruption of the drainage and irrigation facilities. And there are methods that will have to be developed on a site-specific basis. Those will be done during pre-design on an individual basis. This is consistent with measures that I've seen done, personally seen done before in agricultural areas, that there are ways to mitigate those, to prevent or to eliminate the adverse impacts to agricultural infrastructure.
So is it the commitment of the project to eliminate all impacts to these water uses whatsoever?
There are methods that are described in here to do that, and that there are to work to minimize those in that process through these implementations of AG-1, GW1, GW5, and WQ11.
Going back to some testimony we heard earlier, however, there's been no assessment of what these waterworks and drainage and other facilities are, however.
Right, so you'd have to come up with individual processes for each location of the potential affected infrastructure. That would be part of pre-design as it usually is.
And that would be carried out in the future by an entity that, or a person, we're not sure who that is, correct?
That would be the commitment of DWR, who is the overall owner of the project.
Is the petition committing right now to carry out all proposed mitigation measures in the draft EIR as conditions of approval?
There were changes in the mitigation measures between the draft EIR, draft EIS, and recirculated draft EIR and supplemental draft EIS. I anticipate that there will be future changes in wording of the mitigation measures in the final EIR, EIS. As CEQA lead agency, DWR would be committing to the final set of mitigation measures in the notice of determination.
So we don't know today what that list is.
That notice of determination will be completed after the final EIR, EIS is completed.
Okay, I'm just going to note this makes the assessment of injury, I think it means that the burden hasn't been carried here, but I'll just move on.
Objection. There's no question there.
So
I
it's
asked that that
sustained.
statement be.
I'm moving on.
Moving on, please.
Yes. Some of the, there was earlier testimony regarding the directly impacted by the footprint activities intakes, and then as well as the waterworks we have just been discussing that could be disturbed. Are some of those changes could require petitions or changes here at the Water Board, correct?
That's correct.
Are those proposed changes part of the petition being presented and discussed today?
I don't believe they are. We do not have specific knowledge as to what those changes are, so it'd be premature to bring those to this board.
Would that be part of some later proceeding?
That is my understanding, that that would be part of a later process.
With respect to relocating intakes that requires flood levee encroachment permits, would that also be a future application? Well, let me back up. You're aware that in order to move an intake, in addition to Water Board, there's also jurisdiction of various flood control agencies.
Yes.
So I guess there may be future applications then for those changes as well?
Yes, that is correct.
Moment, let me. Earlier we heard from Mr. Bedardsky, sorry, I'm not doing your name correct. Say it one time, Bedardsky?
Bednarski.
Bednarski, thank you. We discussed how, well, quite a bit we've discussed how the engineering designs aren't complete. And you testified that you would complete it when the funding was available. Do you know when that funding would be available?
Objection misstates his testimony.
Ms. Meserve just asked the question rather than trying to rephrase his testimony. Thank you.
Do you know when the funding would be available for the future phases of work?
No, I do not.
Do you know where that funding would come from?
No, I do not.
Are you continuing to work on engineering for the project at this time?
I am currently supporting the program director and program manager as a member of the design and construction enterprise.
But you don't have funding to do the later steps of engineering that we've been discussing?
No, we do not.
I want to just clarify one other water rights. I mentioned I was going to ask a question for Antioch, and I think I have the same question for him that I asked about the other intakes I had identified. Is I wanted to clarify whether in your engineering you had considered water impacts to downstream users such as Antioch in your engineering work.
We did not as part of the engineering team. That would have to be referred to the modeling group.
Had a question also about on page 23, you discussed the component of the project head of Old River Barrier. Let's see. Does this barrier have to be removed when the temporary barrier has to be removed when the CFS goes up over 7,000 CFS? Is that right?
I am not aware of the operating requirements for that barrier.
Are you aware of any component of the project that would include strengthening the levees if more than 7,000 CFS would be allowed to go through that area under the project?
I am not aware.
Can you characterize another thing that I don't think really got covered in the testimony, and I think is part of engineering, is and does have impacts on legal users of water, is the construction period, which we've touched on. But what's the length of the construction period?
The actual construction period is about 13 years.
In your judgment, will it be possible to do all the same farming operations and water uses that are going right now during that construction period?
I think with the absence of the areas that will be affected by the construction footprints, it is our goal to ensure that the rest of the farming operations go on as they are now.
Do you know of any project? Have you ever worked on a project of this scale and magnitude before?
Not on a $15 billion program, no, I have not.
Have you ever worked on a project that was 13 years in length or more?
Yes, I have. With my home company, the Metropolitan Water District, the Inland Feeder Program. It was a decade-long program.
During that time, were there issues with the affected landowners that had to be resolved that you worked on?
Objection, what's the relevance here?
Ms. Meserve?
I'm just trying to understand what the plan is. I'm hearing there's a lot more stuff that needs to get done. My clients are concerned about what's going to happen. And so I'm just trying to find out what their head engineer knows.
About a project in Southern California that's not part of what the proposal is here.
That's fair. Ms. Meserve, okay. Tie your questions to the project before us.
Yes, ma'am. Okay. Notes. I guess one other question just with respect to your knowledge of the project, Mr. Bednarski, is have you traveled to all the places within the Delta that this project would have construction activities on?
Not every single location, no.
Have you traveled around the North Delta, the maps I was showing you today?
I've traveled in the area of the intakes, the intermediate FOREBAY, and some locations along the tunnel alignment.
Right. I think I'm going to wrap up my questions there. Thank you.
Thank you, Ms. Meserve. Let's take a short break, and then we'll try to leave a little bit early today. So let's resume at 2:45. That's a 5-minute break. Welcome back. It's 2:45, and we'll resume with cross-examination of panel number 2.
Prior to doing that, can I ask a timing question?
Yes, Mr. Jackson.
I thought I heard you say that we might leave a little early today.
We'll see. Do you have a specific request?
Because I think there's a lot more, and I was just wondering, will we go to 5? I mean, it's 3 hours home. It's Friday night.
I hope to not go to 5 o'clock. I would like to break around 3:30, but I want to gauge and see how the cross-examination goes.
Thanks.
I take it that you're not objecting to leaving at 3:30 or so.
No.
Right.
Since I'm going to be back Monday night.
All right. Group number 20, I assume Mr. Wilson is not here. Not seeing Mr. Wilson. We'll move to group number 21.
Thank you. Dean Reese for the Central Delta parties. Good afternoon. I had a lot of questions, but as luck has it, when you wait till group 21, most of them have been asked, so I'll try to just ask the few that I still think I have a little bit of confusion on. Earlier in your testimony, Mr. Bedarsky, you indicated that you discussed that there would be some impacts to local water right holders, that group of about 15 folks. Do you recall that?
Yes, I do.
And I believe you said that the goal was at some point those folks would be made whole, and because of that you didn't consider it to be an injury to them, but rather an effect or an impact of some sort. Is that a fair assessment?
That's correct.
And then just a little while ago you testified that one of you testified that the construction period is about 13 years. Is that correct?
That's correct for the entire program.
How long of a period of time were these 15 or so water right holders, how long will it be that they're impacted or they're not whole, or until they're whole, I should say?
Well, let me back up a minute. The construction duration for the intakes is anticipated to take 3 to 5 years, and that will be sequenced within the overall schedule of the construction for the entire program. The impacted diversions will be modified prior to construction starting or during the construction process such that they do not see an interruption in their deliveries.
How long is it overall that they will be impacted, or until they're back to where they were, so to speak, before they were interfered with?
Can you be more specific about what you mean when you say back to where they were before the work started? I'm not sure what you're referring to.
I'm trying to understand how it is specifically that these 15 or so water right holders are going to, how they're going to be impacted in terms of for a length of period of time, how that's going to actually work.
Can you specify what you mean by the impact to them?
I mean, is there a period of time where they're not going to be able to have the typical diversion that they're used to, that they've had in the past because of the project? Is that fair?
No, that will not be the case.
How will that work then? How will they not be impacted by the project?
We will sequence any modifications to their existing system such that there's a transparent or smooth transition from whatever new facilities we provide to their existing facilities.
I appreciate that. What does that mean, you'll sequence that in? I just don't quite understand that. Could you explain that a little bit further?
Well, construction work takes place in a series of activities. I would anticipate that once we get the approvals to move into the next stage of design, that we will look at each and every one of these locations and come up with a specific plan, whether it's extending existing infrastructure or modifying existing diversions in the river, and developing a plan that ensures that they are not without their either quantity or quality of supply for any time that would injure them.
Appreciate it. You don't have that plan developed as of yet?
No, we do not.
And forgive me if you already answered this earlier today. Do you have estimation of when you will have that plan in place?
I do not. It will be developed during the preliminary design stage of the project.
I just want to move on quickly to your testimony with regard to groundwater and we've talked a lot about recently, the last couple hours or so, about the slurry walls. Ms. Buchholz also has referred to that in her testimony, her memorandum, which is DWR 218. My question is, when was it that, well, what was the purpose of preparing DWR 218?
So in the draft EIR EIS and in the recirculated draft EIR EIS, the mitigation measures were suggested to minimize or avoid the impacts on adjacent parcels, groundwater wells, especially at the intakes and at areas, that the entire construction zone be surrounded by slurry walls, so we could just dewater within those slurry walls as described in DWR 218. In the preparation of the recirculated draft EIR EIS, that recommendation was included for the intakes in the project description, but the Chapter 7 groundwater team, which I manage, did not catch that change, and it's shown in the recirculated draft as a red line strikeout change. We did not pick up on that change, and therefore we left that impact as being significant and unavoidable to the adjacent groundwater wells in the recirculated draft EIR EIS. So the purpose of the memo was to acknowledge that we should have seen that change in the project description, and including that change in the project description would reduce that impact to adjacent wells to less than significant.
Previous to this memorandum, this DWR 218, when the environmental document had considered, as you said, it considered it to be significant, unavoidable, and adverse.
Mm-hmm.
Having that been the case prior to the preparation of this memorandum, would you have considered that impact on local groundwater users to be injurious to them?
What we did in the mitigation measures, we talked about several mitigations, such as drilling the deeper wells, or moving the wells, and potentially even bringing in additional water supplies from other areas. However, we did not know at the time, because we don't know the locations, and we still don't know the locations of those wells, that we weren't sure that we could reduce that adverse impact to a level of less than significance, and that's why it remained significant and unavoidable in the recirculated draft EIR EIS and draft EIR EIS.
In your memorandum, the DWR 218, it's your estimation that change in the project, if implemented, would result in now a less than significant impact?
I do believe that, yes.
And as far as these slurry walls go, in terms of how they work, you mentioned a couple of times, I think a little while ago, and I'm not as technically versed as you are, so forgive me, but you mentioned an appropriate level of clay strata available to make these slurry walls work. Is that correct?
Right. So you go down to an impermeable layer. It could be clay or it could be rock, and that's what you're hoping for. If we don't hit that, then you can grout into the bottom of that.
If you have to grout, is that because there's not enough clay that you would normally like to have? You
may not have a deep enough or a continuous impermeable layer, yes. And it's a standard method of construction. I've been on sites when we've done that.
Does the use of grout, because there's not enough clay, does that have an impact on the effectiveness of the slurry walls?
I don't believe so, but I'll ask our structural engineer. If he
should not have any effect at all. Should not have any effect on the effectiveness of the walls.
Do you know, in fact, in the areas of the intakes where these slurry walls would now be constructed around the entire intake facilities, is there an adequate clay layer, a continuous clay layer as you described it? Do you know if that's available?
Don't know that yet.
What will it take you to know that?
We will have to get on the property and do some geotechnical investigations.
And the use of these slurry walls, generally, is there any correlation to their effectiveness in a delta environment like this relative to the time that they would be in place? In other words, if they're in place for a short period of time, are they more effective? Or if they're in place for a longer period of time, do they tend to have less effectiveness in an environment like this?
I'm not sure I understand the question.
Well, let me ask it this way then. How long do you anticipate that these slurry walls, now as described in your memorandum DWR 218, how long do you expect them to be in place?
They're permanent structures.
And whether or not there's enough clay layer or not, you still anticipate that they'll be fully effective?
Yes.
Do you know whether or not the new draft BA speaks to whether or not there's a continual clay layer available in the area where the slurry walls would be constructed?
The draft BA did not address the groundwater aspects.
Was DWR 218, was that prepared for the purposes of this proceeding?
It was prepared during the period of time that DWR was preparing for these proceedings. However, it was also prepared because as a member of the consulting EIR-EIS team, we needed to inform the DWR and Reclamation as the lead agencies of the final EIR-EIS of a change in the impact analysis.
Who directed you to prepare that memorandum?
When I realized, as the project manager of as the consulting team, the portion of the consulting team was doing this, I felt we better explain that to the two lead agencies as soon as possible.
Badarsky, earlier in your testimony, your direct testimony, you described, I believe, the existence of proposed state-of-the-art fish screen facilities for as part of the project. Is that correct?
That's correct.
Okay. Are any such fish screen facilities proposed to be included in any of the existing South Delta facilities as part of this project?
No, there's no fish screens in the south part of the Delta as part of this project.
You know why that's the case?
I do not know why.
If I may, Madam Chair. In Appendix 3A of the draft EIR-EIS, we refer to a series of studies that were conducted by DWR and Reclamation, U.S. Fish and Wildlife, National Marine Fisheries Service, and DFW shortly in the early 2000s, attempting to see whether a fish screen could be constructed at the weirs at Clifton Court, FOREBAY. And there were a number of technical reasons that could not occur at that location to both meet the fish screening criteria established by NMFS, National Marine Fisheries Service, and U.S. Fish and Wildlife Service, and also just the way the flows go around the weir openings at Clifton Court, FOREBAY. We've addressed that in Appendix 3A of the draft EIR-EIS.
So is that to say that your opinion as an engineer that it's not feasible to construct adequate fish screens or beneficial fish screens in the South Delta?
I personally reviewed those reports when preparing that appendix, and the results and the recommendations in those reports appeared to be appropriate to me.
Just a last couple of questions that I've got here. How will, and forgive me if I've missed this in your earlier testimony, how will water flow from the 3 intakes to the intermediate forebay? Is that strictly by gravity?
Yes, it is.
So does that then mean that the intermediate forebay will be at a lower elevation than the water elevation in the river at the 3 intakes?
Yes.
I don't have any further questions.
Thank you, Mr. Ruiz. Group number 22. 23. 24. 'You must be Mr. Keeling,
I am.
since you do not look like Jennifer Spoletta.
Well, I will be if you insist. This is my first time before this tribunal, and I was very pleased this morning. I'm very grateful. I learned that this is Friday. That's good for me because this is my casual attire.
Well, you are wearing blue and gold cow colors, so.
Wait a minute, I'm
Very
a
good.
Stanford man.
Uh-oh.
This is an accident. This is an accident. I think we have the axe.
Mr. Keeling, I think you just ran out of time.
Is this on?
Sometimes you just have to pull it closer.
Good afternoon, Mr. Bednarski.
Good afternoon.
Tom Keeling. I'm here on behalf of the County of San Joaquin, the San Joaquin County Flood Control and Water Conservation District, and the McCollum River Water and Power Authority. A preliminary question. In DWR 57 at page 1, testimony, you write, the engineering project description is based on the engineering completed to date for the CWF, unquote. I just want to know how much of the total engineering has been completed to date, if you can give me a percentage.
We estimate that about 10% of the engineering has been completed so far.
90% has yet to be done?
That's correct.
Thank you. You may recall that there was some discussion this morning based on your testimony, DWR 57 and State Resource Control Board Exhibit 3, specifically with respect to the map book figure 3-4 concerning borrow sites. Do you remember that testimony?
I don't recall a discussion about borrow sites in particular.
Or storage and disposal of spoil. Maybe I was having a dream. It is true that there will be borrow sites for storage and disposal of spoil?
Yes, I believe there are borrow sites that are identified on the project.
About how many?
I don't recall.
What does spoil consist of?
I don't believe I use the term spoil. I believe the term we're using is RTM, reusable tunnel material. That is the material that's excavated for the tunnels and then brought out and stockpiled at the locations identified in the map books.
Usable tunnel material.
That's correct.
Okay. You heard the word spoil used to mean the same thing?
I have not personally. The term that we use is reusable tunnel material.
Heard the word muck used to?
Yeah, that's an industry term that's used quite regularly.
Right. What does this reusable material consist of?
It consists of the silts, sands, and clays and other material that's excavated from the tunneling operation.
Have you done any analysis of the extent to which that reusable material will have a component of hazardous or toxic material?
We have done some very limited testing initially. I believe that is in one of our exhibits.
Have you outlined mitigation measures to address that possibility?
We have a series of mitigation measures. I don't recall specifically where they are in the EI or EIS that speak specifically about how the reusable tunnel material is to be stockpiled and treated and processed.
What is the quantity, and I'm talking cubic feet, what is the quantity of reusable tunnel material you anticipate?
We're looking at about 25 million cubic yards.
What would that be in cubic feet?
We need to multiply that by 27.
I'm trying to get a sense, and I am a layperson, and I apologize for that. My engineering stopped at erector sets when I was 10, so you guys are the experts. I'm just trying to get a sense of the size. By comparison, you're familiar with the Great Pyramid of Giza, are you not?
Haven't been there.
Seen pictures of it?
Yes.
Surprise you to know that that consists of 91 million cubic feet material?
I'll have to take your word for it.
Well, I'm trying to get a comparison. What did you say that was in cubic yards?
25 million.
5 million cubic yards. You don't have any, can you tell me how if I were right about the pyramid?
675 million cubic feet.
675 million cubic feet.
Yes.
Very good. You were the guy I always looked at in the math test and said, "Psst, what is it?" Thank you.
Only a Stanford guy does that.
Waiting for that.
This is going to get out of hand. To what use will the, well, given 675 million cubic feet, how deep will those spoils be? I mean, in depth-wise, do you know?
Objection vague. At which location is the questioner referring to?
Will it be a uniform depth, or will it vary from site to site?
It varies from site to site. Down at Clifton Court, it's about 11 feet. Bolden Island is about 6 feet. And right around the intermediate FOREBAY, we're talking about 14 feet.
Well, looking at those numbers, let's say it were 10 feet on an average. I don't know what the average, but if it were 10 feet, how much area, and I'm talking square footage, would that cover, given the fact that you have 675 million
down at Clifton Court, we're looking at about 900 acres. And at intermediate FOREBAY, we're looking at close to 500, 600 acres. At Bolden Island, it's about 1,200 acres.
1,200?
Yes.
So that's 2,600 acres. Even a Stanford guy can figure that out. Are there any other spoil sites?
No, that's about it.
What do you intend to use these spoil sites for after the project?
The plan at this point is to resurface them with the topsoil that's been removed prior to their placement there, and replace that on top of the spoils.
That's because the spoils themselves will be relatively sterile for agricultural purposes.
I'll take your word for it.
I'm asking.
I think that that's yet to be determined. We've done some initial studies. I don't recall the specific results about whether it would be suitable for growing anything or not.
You have not completed an analysis of the suitability of these spoil sites for agriculture?
That's why we were putting the topsoil back on.
Thank you. At DWR 57, pages 17 through 18, which you could put on the screen if you like. I'm sure you have it in front of you. Your written testimony indicates that tunnel construction will use closed-face, pressurized, soft-ground tunnel boring machines, abbreviated TBMs, in alluvial soils at depths greater than 100 feet with, I'm quoting, relatively high groundwater pressures and earth pressures. Have I accurately described your testimony?
Yes, that's correct.
This morning, you will recall that you testified a bit about those high pressures. I believe you used 65
Pounds per square inch.
Pounds per square inch, yes. And you showed one photograph of a machine, and you showed a beautiful schematic, a very cool schematic and video about this boring machine. I'd like to ask you a few questions about the machines. You mentioned a few projects, and I think you mentioned San Diego or Seattle, Florida, that have used similar machines. Can you tell me what those projects are? Can you go down the list?
Objection relevance.
I want to find out, Madam Chair, about the injurious effects, if any, of this project and construction of this project in the San Joaquin Delta. In order to do that, I have to know about what the construction involves, noise levels, other disturbances from these machines. So, and I don't have an example. So I'm asking.
I guess I hear you. To what extent, Mr. Bernowski or anyone else, are the site conditions similar between those projects and this one? And would those site conditions make any difference to the way the device is operated?
I think in my testimony I mentioned 4 specific project locations. I mentioned a project in Sacramento, a project in Seattle, a project in Washington, D.C., and a project in Miami. The one that would be closest in similarity would be the project in Sacramento. It's a 12-foot diameter tunnel.
Okay, let's focus on that then, Mr. Keeley.
All right. You say the bore width for this, if I may, let me back up. You cited all of these examples this morning to show that this technology was well established, did you not?
Yes, I did.
For the purpose of reassuring these decision makers about the well-established and predictable nature of this technology, did you not?
Yes, I did.
So you used all 4 examples for that purpose, right?
I used those examples as these are areas that these types of machines are being used in.
Was that really true? In Sacramento, you indicated it's a 12-foot bore.
I did not say that. My understanding is it is a 12-foot sewer pipe. I do not recall the exact diameter of the tunnel boring machine that was utilized there.
What's the width of the tunnel that was bored?
My recollection is it was approximately 15 feet.
That's not 40 feet, is it?
15 is not 40, no.
You must be from Stanford. Were any of these projects 40-foot bores or 40-foot tunnels?
Yes, the project in Miami was approximately 42-foot tunnel boring machine. The project that's currently underway in Seattle, I believe, is about 57-foot.
How long, I'm talking about length, was the boring in Sacramento with the 15-foot boring?
My recollection is it was about 3 miles. I wasn't involved in the project. It's just what I had researched in the past. That's my recollection.
With the 56-foot boring in Seattle, how long is that tunnel?
I believe it's a little bit over a mile.
And with the Miami boring, how long is that?
That was about the same.
A mile?
Yes.
Were any of these...
Let me add to that. It's actually 2 bores,
right.
each about a mile.
It's true.
I'm glad you mentioned that. That was my next question. Are these all single borings or double borings?
Yeah.
All of them double?
Miami's double.
Miami, that's the only example.
Sacramento is single?
I believe so.
Seattle is single?
Yes.
For the Sacramento boring, the 15-footer, how deep is that?
I do not know.
For the Seattle boring, how deep is that?
I think at points it's around 120 to 125. It may even go deeper than that. I don't exactly know.
And I'm sorry, that was 3 miles?
No, I believe the tunnel in Seattle is a little bit over a mile long.
1 mile. And the depth of the Miami boring?
I believe directly under the channel it's about 40 feet.
Are all 3 of those projects, Miami, Seattle, and Sacramento, completed?
Sacramento's completed.
Miami's completed.
Miami's completed. Seattle's underway.
Are you aware of any engineering obstacles encountered in the Miami project during construction with the boring machine?
No issues with the boring machine itself. There was extensive grouting that they had to do in the soil.
For reasons related to the previous testimony here with respect to clay, rock, or in the absence of either, the need for grouting?
No, I believe they had a very porous limestone that they were mining through, and they had to grout to basically seal all the voids in the limestone or some coral formation in order to be able to mine through there.
Are you aware of any cost overruns on any of those 3 projects?
I'm going to object at this point. We're getting into the details of projects that are geographically disparate, and at this point, I'd like it if we could focus on what this panel's actually here to testify about, which is our project.
Mr.
Madam
Keeley?
Chair, I did not raise these other projects as examples of the use of these machines to persuade you that this project should be approved. They raised them.
And I'd like to know what the financing of a foreign project has to do with the engineering aspects of our proposed project.
I'll withdraw that question.
Withdraw that one, and if you could wrap this up, because you've made your point with respect to the use of those examples.
To wrap it up very quickly, you referred to the 15-foot boring in Sacramento. Has there ever, to your knowledge, been a wider tunnel bored in the Delta?
I'm not aware of that, no.
What analysis, if any, have you done with respect to the noise measured in decibels or any other recognized increment made by these machines?
Didn't do that before. Sorry. In the draft EIR, draft EIS, and the recirculated draft EIR, in chapters 23, the discussion of noise at both the noise considered at the shafts where the materials would be moving around, moved out of the tunnel and into the areas for transport to the storage, and also associated with the noise inside the tunnels on the surface due to the construction within the tunnels. Those were addressed in decibels in Chapter 23 of the draft EIR-ES and the supplemental draft and the recirculated.
Is there information in there, and it's been a while since I read that, indicating what the noise level would be in decibels from, say, a mile away from the boring?
What they looked at in this process was in the immediate vicinity of the construction and found that it was less than significant even to sensitive receptors in this area. So they did not go out to a mile.
How many hours during the day would you expect the boring machines to be operating?
They could be operating 20 at any time during a 24-hour cycle, anticipating that they would work approximately 5 days a week.
24/5?
Yes.
By the way, what do you intend to do with these machines? How many machines do you intend to use for this project?
I believe we're anticipating at this point about 12 machines.
What do you intend to do with these machines at the end of the project?
Those machines will be owned by the contractors that operate them, and it will be up to their discretion what they do with those machines.
I couldn't tell from the schematics in the video, how large is each of these machines? I mean, it's obviously larger than a VW, larger than a bread box or a bus. Is it the size of a city block? What is it?
They could be upwards of 300 to 400 feet long with all the equipment that's connected to the actual cutting part of the tunnel boring machine.
And the other dimensions, width and height?
Well, it's 40 foot. Well, we're anticipating it's a 45-foot diameter machine, so everything will fit within the 45-foot diameter.
I believe you testified earlier that the project was to continue for 13 years? Construction?
The construction activities, I believe that the tunneling activities will be completed within 10 to 11 years of that.
Going back to the topic that's recurred throughout the day, the 5 anticipated permanent relocations of diversions in the intake area and the 10 temporary relocations. By temporary, what duration do you mean?
What we've characterized as temporary is that we will not be removing as part, or we do not anticipate removing the portion of their diversion that goes out into the Sacramento River. In those areas that we call permanent diversions, we will be physically removing that portion of their diversion that goes into the Sacramento River along the levee. So if it's categorized as temporary, it means that we will basically replumb their part of the system that's on the land side of the river. And then, as I mentioned, as I explained to one of the other individuals, we'll reconnect those so that the users have basically a seamless supply of water and quality at their present levels.
Will the 5 permanent relocations require permits for changes in those points of diversion?
I anticipate that they would, yes.
Will the temporary relocations require such permits?
At the present time, we're not anticipating that they will, because we're not going to impact their actual connection to the river itself. We will be modifying downstream piping and pumps, but not affecting where that diversion enters the river. So the short answer to your question is no.
With respect to the 5 permanent relocations, then, what entities, if you know, would be making those applications for changes in the points of diversion?
We will be working with the present landowner that controls or owns that diversion, and I believe through our discussions with them, we'll determine whether they would want to do that or whether DWR would want to do that. But we would be prepared to do that if the owner of the diversion did not want to. DWR would take that responsibility.
But no applications have been filed yet for those changes in points of diversion?
No, they have not.
What contingency plans, if any, have been made to address the consequences to the project if one or all of those requested change permits are not granted?
I think that at this point in time, we'd have to take that into account as we would other things that would occur during the pre-design. There'll be we will probably have to make some decisions that we may need to come up with Plan B, but right now, all of our plans are as established in the project description that we have right now. And it may mean changing locations of something, but I think that's really speculative at this time.
But nobody's assured you that they will be granted.
Nobody's assured us, but it's like with the rest of the project description, it's defined, and we've done the analysis based on the definition of the project description that we have in front of us right now.
For construction of the California WaterFix, did you request any approvals at all from the Delta Stewardship Council?
I'm not aware of any that the engineering team has requested.
Have you ever been told, I know you're not a lawyer, I'm not asking you for your opinion, but have you ever been told that the proposed project would be a covered action under the Delta plan?
The engineering team has not been told that.
Have you performed an analysis of the impacts of tunnel construction on San Joaquin County's efforts to comply with the mandates of the Sustainable Groundwater Management Act, earlier referred to as SGMA?
To the best of my knowledge, the engineering team has not been requested to do that.
Currently, the recirculated draft EIS identifies SGMA as a cumulative impact, and that the knowledge of the groundwater sustainable plans, GSPs, are currently being developed and would be speculative to identify specifics, criteria that would need to be complied with in the future.
So
So the answer is no, they're a cumulative project.
So the answer is no.
No, but it's recognized that it is a future project. I do not know, and the groundwater analysis did not analyze individual wells. We recognize that that would have to be done during the preliminary design phase of the project.
During my duration on the project, I'm not aware that we have.
Mr. Keeling, please get closer to the microphone. Thank you. No, that did not help. Is your microphone on? Stanford.
Did your engineers meet with any engineers from reclamation districts in San Joaquin County about the construction of this project through their RD jurisdictions?
I don't have a specific reclamation. I don't have a specific recollection of any meetings that have taken place, although we're generally aware of the fact that we will have to do that in the upcoming stages of design.
Did your team, were you provided with any study or analysis of the effects of tunnel construction on specific aquifers in San Joaquin County?
No, we were not.
Were you ever provided with any study or analysis of the range of possible effects of tunnel construction and tunnel operation on aquifer recharge efforts in San Joaquin County?
I'm going to object to this compound question if he wants to rephrase it and break it in two.
Please break that up.
Were you ever provided with a study of the effects of tunnel construction on aquifer recharge efforts in San Joaquin County?
We have not, I've not reviewed anything or seen anything or heard about anything of that matter.
Mr. Keeling, I'm sorry, before you continue, let me check in with the court reporter since I shortchanged her on the last break. Do you need to take a break? You good? All right. Thank you. Please continue, Mr. Keeling.
Have you ever been provided with a study of the effects of the operation of the tunnels on recharge efforts, aquifer recharge efforts in San Joaquin County?
I have not seen any such study.
Have you done an analysis of how many NPDES permits will be needed for tunnel construction?
We did not quantify that as part of the environmental document. We recognize that during pre-design, the specifics for dewatering will be determined at each site, and there will, depending on the methodology for disposal of the dewatering water, we would have to consider NPDES permits if the water was discharged back to the surface water bodies, usually post-treatment, to remove sediment and anything else, any other constituents that were necessary. And we also have anticipated that there would be one or maybe just a few stormwater NPDES permits completed for the construction processes for the non-stormwater discharges off the construction.
But you don't know what conditions might be imposed in connection with the issuance of those permits?
No, that's always something that's done during the pre-design project.
You know that in fact any requested NPDES permits will be issued?
We recognize that we will definitely need them for the construction under the stormwater discharge. That's mandated in California. And if we're discharging dewatering water back to the surface waters, we will need an NPDES permit for that.
The question is actually a little different. You answered the question about whether you'll need them. I'm asking whether you know that if the permits will be issued.
Objection, speculative.
Right.
So you don't know?
We would apply.
Same objection.
She can answer no.
No, right.
Well, on dewatering, can you give an estimate of how much groundwater you estimate will be pumped during construction of the intakes?
We have not done that analysis now that we've looked at the construction methods with the slurry walls around the entire construction footprint. We have not completed that, no.
You have an estimate of how much groundwater will be pumped during the construction of the tunnels?
We have not done that, as I've said, with the slurry walls at the tunnel shafts. We're not anticipating any groundwater. The groundwater part that would be coming in with the reusable tunnel material is part of the volumetric analysis of the tunnel material when it's returned.
Can you provide an example to us of other dewatering projects similar in size and scope to this project's dewatering component?
Have I provided you that?
Could you?
Could we? From the size of of each of the three intakes and of multiple intakes, I'd say probably one of the ones I worked on as permit engineer during construction was we were responsible as construction manager. The firm I worked for is we were construction managers for 3 large wastewater pumping plants for Monterey Regional County Sanitation District that were constructed along the beach of Monterey Bay. And in that case where we had to use slurry walls and the grouting procedures because otherwise we were fighting a losing battle trying to dewater the bay. So I don't mean to be flippant, but
I understand.
It was a massive job. And we had the connecting pipelines that went with it. It wasn't a tunnel operation. In that case, it was open trench, and it was a challenge.
You would compare that project to this one in terms of the size of the dewatering?
For the intakes as well compared to those wastewater pumping plants, absolutely, in size-wise.
Will you be testing the quality of groundwater before dewatering?
Yes. And during dewatering operations, that testing's mandated by the state of California.
And after?
And well, it would be, as we withdraw it, we would be doing testing and prior to discharge or disposal methods.
Will that data be publicly available in connection with this project?
It generally is part of the, it's certainly publicly available because it needs to be submitted to the Central Valley Regional Water Quality Control Board in this instance.
And what will you be doing with the pumped groundwater?
That's going to be determined in pre-design, which will depend upon the rate, the timing, the production of that groundwater. I've been on projects in which we've been able to discharge it after treatment to an adjoining surface water body. I've been on projects in which we've hauled it away. It'll just really depend on pre-design what'll happen.
So at this time, you don't know?
We don't have it. We've covered it in the environmental impact report, so the range of potential disposal methodologies.
What are your contingency plans to address situations in which groundwater samples show reductions in the quality of water that would affect legal users downstream? It's anticipated that the NPDES permits would not allow us to compromise the downstream water quality, and therefore, if that occurred based upon our groundwater samples prior to dewatering, treatment processes would be put in place. How large are these proposed dewatering pumps, by the way?
I don't believe their size has been determined at this point.
Do you know how many of them you'll need?
No, we do not.
Would they be operated 24/7?
It would depend on the specific application, whether they were or not.
Your experience, what is the usual time per week of the operation of dewatering pumps in large dewatering projects?
Well, I would assume that in an uncontrolled environment, like had been originally proposed, they would have to operate continuously to keep the groundwater level down. I'm not sure that now with the confined situation that we're anticipating with the slurry wall construction, that we would necessarily need to operate those pumps 24 hours a day.
So you're not sure about the time of operation yet of those pumps?
We'll determine that once we're able to get some geotechnical information and begin our preliminary design.
Same question with respect to seasonality. Do you anticipate the pumps will be used throughout the year or just during certain seasons?
I don't have a specific answer for that. I would assume it would depend on the groundwater levels and how they're responding or changing during those different seasonal conditions.
If I may add to that too, at the intakes, especially well, at all of the construction sites, but especially at the intakes and the tunnel shafts, once after we construct the slurry walls and we put in the groundwater pumps and dewater and we make the site impermeable so we can do construction, we should not be doing major dewatering for long after that. There'll be a little bit of tail off water time and we'll do it, but once it's dry, it's dry. And then we're constructing an impermeable structure.
Have you done an analysis of how the discharges might increase water levels in local sloughs and channels during the wet season?
With respect to the intakes, we're adjacent to the river, and I would anticipate, and we've talked about this in the document, that those discharges would probably go back either into the river or to somewhere close to the confluence of the river and adjacent sloughs so that we wouldn't be backwatering up to affect adjacent properties. And with respect to the tunnel shafts, it's going to have to be dependent on each location because many of those are interior to an island. And so we're going to have to work on a site-by-site basis to come up with something so that we don't affect irrigation drainage or raise the adjacent shallow groundwater that could affect root zones for our adjacent agricultural crops.
Do you have any more detailed plan for that at this point?
No, that's all a pre-design aspect.
And finally, has the team made any requests for encroachment permits from reclamation districts in San Joaquin County with respect to levees and other reclamation works that might be affected in that county?
Not to my knowledge, no.
Do you have any plans to do so?
Once we move into the next stage of the project, preliminary design, we would begin that process.
I'd like to thank this panel for their attentiveness and their time, and thank you.
Thank you, Mr. Keeling. All right. Does anyone object to us adjourning at this time? All right. Not seeing anyone. Everyone's able to return next week. All right. With that, then, thank you all, and have a great weekend. And we will see you next Tuesday, 9 o'clock.